We would like to introduce for you, gentlemen, ladies and gentlemen, Mr. Paul Keller. Mr. Paul Keller is an ASR certified from NADCA. He's specialized in the systems air duct cleaning, and he is one of the distinguished lecturers with NADCA related to the standard of NADCA related to HVAC systems cleaning. Today, our presentation is very important since we are not really doing a good role in really cleaning the HVAC systems in the past, let's say, many years. That is where the HVAC systems are introduced to our region since maybe 40 or 50 or 60 years, whatever. And we are now, let's say, confident that something should be done related to HVAC duct cleaning, not even due to the COVID-19 pandemic, which we are really living right now. It should be done because of many, let's say, dirtiness, and many problems will be there in the HVAC system, which will Mr. Paul, within the coming 5 to 10 minutes, he will start his presentation, and he will introduce us to that standard and how we clean our systems properly according to a certain standard, not according to somebody's practices or his own practices. So please, Mr. Paul, bear with us another like 7 minutes more, and in 1:55 Jordan time, which is 6:55 your time, we will give the mic to you to start your presentation. We would like to introduce yourself more and talk about the, let's say, what you want to talk about in general, and we will start 7:00 sharp. For the gentlemen and ladies who are attending with us, we will leave the last 15 minutes from the presentation of Mr. Paul for the questions and answers. So if anybody wants to ask a question, he can put it in the question and answers down in writing, and Mr. Paul will read it, and he will answer it right after his presentation. If anybody wants to write his question in Arabic, we can translate the question to Mr. Paul to answer it. This will be the way that we will conduct our meeting today. We hope that everybody will enjoy the presentation and the topic that Mr. Paul will present to us. Thank you very much, and we will wait for 6 minutes more, and Mr. Paul will start introducing himself more and elaborate on what he's doing exactly. Thank you very much. Okay, Mr. Paul, please, you can go ahead, start just introducing yourself and also introduce NADCA to us. And at 7:00 your time, which is 2 p.m. our time, start your presentation. Thank you very much. The mic is yours.
Thank you very much, and I can't thank you enough for having me here to speak today. It is quite wonderful to hear how indoor air quality, especially right now, is impacting the entire world, and especially to see how you guys are taking care of indoor air quality as best as you can in relation to everything that is going on. Because as COVID-19 is here, it has been the best and the worst thing ever that we could experience within our industry, to bring our industry to the forefront and battlegrounds of being able to provide even cleaner, healthier environments. More of a background on myself is that I am a second generation duct cleaner. I've learned this trade from my father. He has been and still is doing this, and has been in this industry for almost 40 years. I rely on him as a mentor, and for us, it's been a great relationship. I tried to run away from this industry, and here I am today, 10 years in, and have no signs of wanting to stop. This is something that I am passionate about, that I have really enjoyed, especially in watching the advancements within our industry continue to grow. The science is becoming more clear. The case studies that are going to be presented in the future here in 2021 will hopefully shed more light on current standards and white papers that need to be addressed, to upgrade our level of cleaning. So for myself, I made sure that I had gone and got an apprenticeship to become to have the more experience to be able to go take a test for where I live here in the United States, as we are required to have an AC license to perform any kind of cleaning service here in Florida. So it's not like that all the way throughout the United States, but those are things that I had to do to get to where I am now. So that is a little bit of background on myself. NADCA, the National Air Duct Cleaners Association, helped give credibility at a time when there wasn't any. And not only that, a collective group of individuals made sure that the ACR, which is the standard we're going to speak about today, helped bridge a gap in what is someone else's protocol to cleaning, as was discussed by Rami, and as well as making sure that there is a specific standard of protocol for how to clean a system with regards to the type of system, to the material that the system is made out of, to making sure that it's done in a safe and a systematic manner. So I do hope that you spend some time reading through the standard once I've completed this, as there's a lot more information that I may not get to within the standard. So please be aware that there is a little bit more light reading to do. And at the end, if there's for some reason that I cannot answer one of your questions at the very, very end, I will be sure to shoot an email back in if for some reason obviously with an answer if I can't do it at the particular time. But I welcome you to ask me as many questions as you would like. I'm more than happy to engage even after this presentation is over. So again, I do hope that you find this as enlightening as it has been for me within this industry, with the ACR standard that has continued to grow and evolve and be a living document for how air duct cleaning or HVAC cleaning should be taking place within a system itself. So does that put me at the time to start the presentation here? I think I still have a couple minutes left. Let's see here. It is 6:59. All right, so let's go on ahead and let's get started here. Let me move the screen a little bit so I can see as we are. Okay. All right. HVAC system cleaning in accordance with the NADCA standards. The HVAC system cleaning in accordance with the NADCA standards addresses three very important and vital areas. And let me go back here. Discussing energy savings, improved system performance, improved indoor air quality. So back in the day, especially energy savings was not calculated. Improved system performance, there was no studies to show that this is you're enhancing a system, even though we were doing this all along. By the main reason why we were doing a cleaning was to improve the indoor air quality. When individuals go in to restore a property, you know, the AC system is normally shut down. That's part of protocol, and it's forgotten. Within the standard, it shows where this should come into play to be able to get into adding the cleaning aspect of what you're already cleaning within the particulate of the air. The system, the systems and the particulate that are within the systems continue to get blown out into the environment. So these areas here are what the NADCA standard really focuses on. The benefits of cleaning the HVAC system. So the United States has a Department of Energy, and they conducted a study here that heating and cooling accounts for almost half of the average of a home's utility cost. That's not even speaking about a commercial facility. If you look at the graph here, you can see 37% is based on heating, just trying to heat a property. 10% down here to cooling. I mean, that 47 total percent of energy usage is just spent on trying to control an indoor environment. Even in new buildings, whether it's a new building or a older building, systems become dirty. They go through a construction process, and not all construction has the engineering controls to be able to keep the building clean during the build out. And these HVAC systems, when they become dirty, they soil the system. And then everyday use, as we bring in fresh air, and as we're trying to understand especially more about COVID-19, we are reintroducing things into buildings now that they're going to have dramatic impacts on the HVAC system. Contaminated heating and cooling systems can be problematic for occupants, contributing to poor indoor air quality, system failures, and increased energy usage. This photo here on the left side of the screen is a blower wheel. The blower wheel has accumulated due to airflow some kind of microbial growth, and it's continuing to grow. And what happens is within the blades there, reduces the efficiency for air to pass across a heating or cooling surface. So if you're reducing the air that this system is supposed to be producing, you increase the likelihood of a system failure. when an HVAC system is clean, it doesn't have to work as hard to maintain the temperature you desire. As a result, less energy is used, leading to improved cost effectiveness. Cleaning coils, heat exchangers, heating coils, add an additional 10% to system performance. This source was found from the National Comfort Institute, which would be a good source to refer back to for general information regarding the comfort of an indoor space. A buildup of almost half an inch of dirt on a heating coil can result in a decrease of efficiency of 21%. That's significant, and that was brought to us by the Environmental Protection Agency. Here's a photo of that blower wheel again, just to show the efficiency loss that you would see if it was obviously dirty, not clean. Here's some photos of some coils to give you an idea of some of the soiledness that goes on with these coils. Here on this right side of the screen, you'll see this is more of a microbial growth based. This here may be more construction based, and if you look up in this upper corner, these filters, this is a filter bank. This coil is attracting all kinds of dirt and sediment within the system that is bypassing these filters. Here is a A-frame coil. Just to show here, this is what the coil should look like. This is the growth pattern that has taken place, or I'm sorry, this is the buildup pattern that has taken place up here at the top of the coil. Let me move this on forward here. Benefits of HVAC system cleaning. Wow, this is a big one. Especially now, sick buildings and indoor air quality. This is just more information that shows and examines what happens when a building becomes sick because of poor indoor air quality, which are things that you're aware of, but if you're taking care of just the general space and not taking care of the distribution source like an HVAC system, you're just recontaminating an area and not fixing the entire problem. And these numbers are very significant when you look at what happens in the case of a building being sick. So, case study article. This is a great one here. Now to get out of the sick building, now to go into how we save energy. Study verifies coil cleaning saves energy. This was done by Ross Montgomery. He's a member of ASHRAE, as well as Robert Baker, also a member of ASHRAE. And this was done back in 2006. The study was that a system is built and put together by an engineer that is supposed to work within certain parameters. Once the system starts to become fouled or soiled or have lots of contaminants within it, the system doesn't operate within the building envelope in some cases. And so to maintain this, we always make sure we clean the HVAC air handling unit and ductwork as necessary. One of the best things that we ever did was to be able to take the coil and isolate it and actually do a case study, which they did, to show how much money was being saved, possibly just by cleaning the coil. The study was conducted in a 34-floor, $1.2 million or 1.2 million square foot building in Times Square, New York, supplied by 4 air handling units totaling 575 tons of heating and cooling. Cleaning the coil showed 25% increase in efficiency, giving back almost 100 tons of cooling lost to dirty coils that had been cleaned the previous year. I mean, within 1 year, this stuff got this dirty. Restoring one of the air handling units resulted in an estimated yearly savings of $40,000. This is beyond significant. The study cites other soft positive results that come from cleaning and normal maintenance operations. Increased HVAC system performance. These systems aren't working as hard. And cleaner HVAC systems do not provide an environment for fungal, bacteria, and microbial growth in their coils and ducts. Therefore, less sick time, less time that people were calling in to not come into work. So based off that study and going back to an original photo, especially here where you can see the before and after photo, what impact do you think this will have on the system? What kind of energy efficiency did we just create within the system? How much money was saved? What kind of indoor air quality did we just enhance? Those things are now becoming very measurable and are a very high priority, especially now within the cleaning of an HVAC system. So just more benefits of cleaning HVAC system. A Pacific Gas and Electric PG&E study shows that a dirty condenser coil can increase compressor energy consumption by 30%. A dirty condenser coil that raises condensing temperatures from 95 degrees Fahrenheit to 105 degrees Fahrenheit cuts cooling capacity by 7% and increases power consumption by 10%, with a net efficiency reduction of 16%. All it is just working so much harder. In a 10-ton unit operating 2,000 hours a year, this wastes about $250 per year in operating costs. I mean, that becomes quite significant if these things can just be taken care of on a normal maintenance program for cleaning. Filtration. Oh, filtration. Is it time for a change? I mean, I don't know how long that filter was left in the system, but could you imagine how hard that unit was working just to cool or heat that space? Here's another benefit of an HVAC system clean, to put more of a perspective as an approximation for what things normally cost here in US dollars. Typical costs of replacing the following component. This is about a 7.5 ton rooftop unit that we have. And the coil, if the coil fails or becomes too dirty and you can't clean it properly, you could be looking at a $1,500 repair. The condenser coil, if it becomes oversaturated with contaminants that don't allow it to function air properly through it, there's a $1,500 repair. Now we're up to $3,000. Condenser fan motor, there's two of them here in this 7.5 ton, $350 each. There's $700. Compressor, $1,200. I mean, you see how all these systems that can fail, and if it gets to the point where it's not maintained properly, an entire replacement could cost almost $10,000 US. That's quite significant if all they had to do over time was just clean the components within inside this system. A typical maintenance checkup is recommended and includes the following components: component inspection and cleaning. This is by the Energy Star. Check and inspect the condensate drain, clean evaporator and condenser air conditioning coils, clean and adjust blower components. Now, here's where we get into what we want to talk about, the ACR, the NADCA standard. The ACR stands for Assessment, Cleaning, and Restoration. And here it is. The standard provides you practical, reliable, and industry-backed information for assessing new and existing HVAC systems, evaluating and verifying, which is it's just part of assessing the cleanliness of HVAC systems, guiding the cleaning and restoration of HVAC systems to a specific level of cleanliness. There is a free download for this for you guys if you go to nadca.com to be able to download this in different languages to be able to have this as a standard. Helps determine the need to clean, helps you have a clear scope of work, so you're not guessing as to what you should have to do. Provides protocols to protect the safety of building occupants and prevent cross-contamination. Helps you understand proper cleaning procedures. Provides quantifiable methods for verifying cleanliness so that you can prove what you did actually improve the indoor air quality. So determining the need to clean. It is recommended that the HVAC systems be cleaned when a proper cleanliness inspection or building history indicates one or more of the following conditions in the HVAC system. Contaminated with an accumulation of particulate, performance is compromised due to a contamination buildup, it has been determined to be a source of unacceptable odors, discharging visible dirt or debris into the conditioned space, has been contaminated as a result of fire, smoke, and/or water damage, has been infested with birds, rodents, insects, or their byproducts, has been determined to be at risk for a fire hazard, has become contaminated with construction debris or dust. It is recommended that the HVAC systems be cleaned when proper cleanliness inspections or building history indicates one or more of the following conditions yet again. Mold contamination, which have reached conditions 2 or 3. This is what I mean by conditions 2 or 3 are here in the IICRC S520. Deterioration of fiberglass duct liner, duct board, or other porous components. Again, now we're talking about the type of material that the ductwork is made out of. HVAC maintenance program as defined by ANSI ASHRAE Standard 180 as part of HVAC equipment manufacturers recommended maintenance practices, as part of proactive energy management program, as part of proactive indoor air quality management program, as a component to achieve LEED certification, when a newly installed component or duct has been contaminated with construction and/or other dust and debris. And as you can see through here, all I did was basically give you more things to go read up on as for determining the need to clean based off of certain parameters that you would find within these other standards. What will you find in the standard? The ACR standard has 5 sections that flow like a project. First, do an inspection. Then, create work plans. Next, place engineering controls in place. This would be like your air scrubbers, HEPA filtrated negative air units. Then we perform the cleaning and restoration procedures based off what we created from the work plan. Lastly, we verify the cleanliness. HVAC cleanliness inspection schedule. So these are when we should go back through this. Right here, residential's 1 year, commercial's 1 year, industrial's 1 year, healthcare's 1 year, marine is 1 year. But please look here, we start focusing in on certain aspects, whether it's air handling unit, supply ductwork, return ducts and exhaust ductwork. These intervals change. This is a good graph to always refer back to when determining the need for cleaning. Provides guidance for the cleaning and restoration of HVAC systems to a specific level of cleanliness, including air handling unit restoration, coil cleaning, resurfacing and coating. And there's 3 methods of cleanliness verification. The first one is just visual, what you see. Does it look dirty? Method 2, surface comparison test. And method 3, the NADCA vacuum test. NADCA's general specification in CSI 3-part format describes minimum requirements to coordinate a successful commercial HVAC system cleaning project. This is another free download that you guys can get at nadca.com. All right. General cleaning requirements. What's included? This is a flow chart to just go through in this order how to evaluate general cleaning requirements. Guidance on developing a proper scope of work, standards to be referenced, required submittals prior to cleaning, closeout, and quality assurance. These are things that maybe you have to give to that building owner or the property owner or whoever may be asking for certain items. Product sections, guidance on execution of the cleaning project and proper cleaning procedures, prevention of cross-contamination, quantifiable methods for verifying cleanliness. Within the ACR, there's certain terms that will be used, and NADCA did a wonderful job of clarifying these things to make sure there was no misunderstanding as to what they mean by certain items. So in this case, visibly clean. An interior surface is considered visibly clean when it's free from non-adhered substances and debris. Definition, what is non-adhered? Any material not intended or designed to be present in an HVAC system, which can be removed by contact vacuuming. If you see here, this individual is inside of a duct with a vacuum, vacuuming up this debris that is there. It's not supposed to be there. Source removal techniques. The mechanical cleaning of systems components to remove dirt and debris requires 2 key elements to be effective: agitation of dust and debris within the HVAC system, extraction of contaminants from the HVAC system. So this first photo here shows a level of agitation. This agitation can be done by a brush of this type. It can be done with a means of air whips. It can be done with a means of contact vacuuming. That is the agitation portion of source removal. The extraction portion you can see here is a negative air unit set up within the duct system. So as you are agitating the surfaces with the components I just mentioned, that you are then pulling it through a HEPA filtration where it's then exhausted to a proper location. Negative pressure. That's used to prevent debris from entering the occupied space or leaving the contained area. If you notice here, the way we go about our cleaning so far, from what you might be able to see, is that it coincides with a lot of the stuff that you already do within indoor air quality and how you clean up an air space. Now we're just taking a lot of that and putting it into the HVAC system. So the negative pressure used to prevent debris from entering the occupied space or leaving the contaminated area. Prior to and throughout the duration of the cleaning process, the HVAC system and associated air duct shall be kept at an appropriate negative pressure differential relative to the indoor non-work area. Basically saying that we're going to control the environment in which we are cleaning. Service openings. Access duct cleaning work through existing or new service openings, allowing safe access and through cleaning throughout specified components. Openings are to be installed so they will not degrade structural, thermal, or the function of the system's integrity, and comply with applicable SMACNA standards and duct construction methods. SMACNA is another HVAC, it's a good way to explain this, is that SMACNA standards are a way that we conform to making sure that ductwork is installed properly. And so certain areas, these service openings, this is a door that they use. It's specially made for this kind of a duct. So that way we cut into it to clean it. We have a way of putting it back together, so that way the system still functions the way it's supposed to. Employ engineering controls to maintain worker and building occupant safety, to prevent contaminating surfaces outside work area. So here you can tell that within the area of where the work is about to begin, 1, 2, 3, 4 air scrubbers have been put in place, negative air units, in this case more so air scrubbers, to be able to control this environment while a cleaning takes place to reduce any cross-contamination that may be going on from duct cleaning. Proper cleaning procedures. Cleaning work should flow the pathway of the HVAC system's design. So I noticed it in the previous session that there were arrows that showed the air coming in and the air going out. Here, our cleaning process takes place of cleaning the return intakes first. So any area where the air gets sucked in, cleaning the air handling unit and its components, and then lastly, working downstream of the air to clean up the supply trunk line and all the branches that come out. Because it doesn't make any sense to do these things oppositely, especially if you got to turn the system back on the same day. This work sequence, when properly performed, is designed to reduce the likelihood of clean portions of the ventilation system becoming recontaminated. Provides guidance for proper cleaning of HVAC system components, including but not limited to air handling units, air duct systems, coils, internally insulated components, sound attenuators. There's more components than this that the ACR addresses to be cleaned within the standard. The HVAC system cleaning can yield positive results. Increased energy savings and efficiencies. These are measurable items. Extended life expectancy of HVAC systems and components, and improvements in indoor air quality. Again, there's the download at the NADCA.com to be able to get a free copy. Summary, again, proper HVAC system cleaning can result in energy savings, improved system performance, improved indoor air quality, the ACR, the standard, and the NADCA general specification provide guidance on cleaning requirements and methods for proper HVAC system cleaning. And both of those documents can be found within nadca.com by being able to go to the search. There's a little search portal by typing that in there. All right, let's see what if you have any questions here.
Thank you, Mr. Paul. Thank you very much.
Okay.
We will open now the door for questions, and we have, Mr. Paul, a question for you. Mr. Jafar Azim, he's asking you about how can we clean the blast valves.
Okay, and I may be a little bit unfamiliar with what you're referring to with a blast valve. Is this are you referring to the area?
It's a kind of damper, Mr. Paul. It's a kind of damper that will be put in the fresh air intakes or some exhaust to protect the building from the blast wave. But it's acting like, consider it as a volume damper, something like that.
Gotcha. So, so the question would be you would need to see how you can access it, okay, to see what kind of accessibility you have to it. From there, there's mechanical means of which you can get to that damper, which I would assume that they're either gravity-based or they are pneumatic, where you can adjust as a damper is concerned. You can drop it, clean both sides as long as you have access to it. And there's probably not enough information there for me to answer that correctly, because I'm assuming you're cleaning the blast valve based off of dust and dirt that's accumulated on it over time to make sure it doesn't jam. Is that what I'm understanding?
Yeah, there is a special mechanism for the blast valves or blast, let's say, blast dampers, where there is some kind of auto close and auto opening. So maybe Mr. Jafar, if he can ask his question, we can allow you to open the mic. Are you with us, Mr. Jafar? Can you raise your hand, Jafar? Okay, Mr. Jafar is there. Let me allow him to talk. Let me open the mic for him. Hold on.
So I would assume that what we're referring to is something like a fire damper.
You can talk now. Open your mic and you can talk to Mr. Paul. You ask your question, please.
Hi, do you hear me now?
Yes.
Yes.
Okay, thank you for such a great session. I would like to ask about the blast valve, that a valve used to protect the indoor facility. It's past the air, but when it sends pressure between indoor and outdoor, like when bomb or nuclear attacks or etc., it will shut down immediately. So we have a blast valve, and I would to ask how I can clean it. I tried to clean it with the water jet, but in fact, the water keep inside the valves. So is there any way to clean these blast valves? You know, when we take the air or the airflow from these valves, it will contain the dirt and dust. So I would ask how can we just clean these valves?
Right. So the best way that I would understand to do something like that would be like how you guys have the blast valves. We have fire dampers, and so what we do in that case is we cut an access very close to the blast valves, or so that way we have maybe an access door close by on both sides. You know, is more preferable. But if you only have it on one side, you attach a negative air, so you increase a volume of a flow of air, and I would utilize like an air compressor. So you can use like blasts of air that exceed maybe 150 psi, as long as it doesn't damage components, it comes on a little tiny crevice. So you can angle it and you can push really hard. So you don't do it with water, so the water doesn't collect in there, because obviously you need a way for the water to come out. But I would do it with air. That way you're hitting it in such a way that when it dislodges, it goes right into the negative air like a vacuum. Does that make sense, what I referred to?
Kind of, but in fact, the problem that we can't just cut the operation to reverse the air flow. It's hard to cut the operation of our property to clean to reverse the air flow so we can clean it. Other question, please, about the duct. We have a wet duct that carry a very high percent of humidity. So what's the interval that we should clean these ducts?
I'm sorry, you're saying you have ducts that end up with high levels of humidity?
Yes, it's reached 90 or 95% relative humidity. Yes.
Okay, so when cleaning the ducts, and I guess you're explaining that things become like sticky, and it's hard to clean things more appropriately within the duct system.
Yes.
So the types of equipment to clean that, especially on the supply side of the air duct system, you're going to use a variety of things, whether it's going to be brushes, compressed air, whips, and if it's metal, and then it depends on the type of material. So if it's metal, you can be very abrasive, and you can dislodge a lot of it, even by contact vacuuming for that matter. But utilizing whips and negative air at a high volume can get a lot of that stuff to come off. I may get a little bit too far ahead, but if it's not made out of metal, there's other ways of cleaning where you are taking the surface contaminants off, and then coming back through it with a coating product that you can spray inside the duct that's rated for the HVAC system with high humidity. So it helps the cleanliness level for anything that wouldn't come off by normal mechanical means.
What is the recommended periods to do it? Annually, every 6 months, or?
So as far as how often?
Yes.
So generally you do a cleaning, and then the next time you would look at a cleaning, you evaluate it for like residential homes, you're evaluating it, on the return duct side every year. Air handling units, you normally evaluate about every 2 years. And then the supply ductwork is about every year. So you want to be able to visually look at it that way. Doesn't mean it's something that always has to be done, but you do want to evaluate it on that kind of a level.
Thank you. Thank you, Mr.
Let me scroll up here. Do you use robots in cleaning ducts? Yes, we do. The duct, it has to be a certain type of duct and large enough for us to put a robot inside of it. There are lots of robots that are being introduced into the market. It's not a one shoe fits all. They all have different applications, and they can be quite expensive. But there is a place for them in the industry, and would be something that I would consider looking at.
Okay, Paul, there's a question in Arabic from Mr. Khalid Musa. He's asking you, is there any indication that he can make sure that the duct is clean and without any, let's say, without inside pollutants after cleaning that? How they can verify that?
Okay, so I understand. Is there any way to verify that the system is clean?
Yes,
or not clean?
Yes,
to determine
or
the level
not
of
clean.
cleanliness.
Exactly. Thank you.
So yes, and so there's different ways of going about doing it, and most of it is in relation to why is the customer wanting the ductwork to be cleaned. So if it's based off of there's mold, then you evaluate the duct system to see, you know, what kind of contaminants within that mold are present within the duct system. If it's for dust and dirt, that's normally a visual test where you're able to just go in and visually look at it. But there are ways to go about doing the tests, but it can be a series of different types of tests. But it's really based off of what is the reason behind cleaning the duct system.
Okay,
I hope that answers that.
that's fine.
And then
okay.
what?
Another question,
what is the?
Mr. Khalid Musa, what is the best procedure to clean the coils?
So this gets asked quite a bit, and it again, being in humid climates, for myself, we do wet cleans, and there's a series of different types of chemicals to use. I would be very cautious and careful to make sure that you're using proper chemicals within the HVAC industry that are rated to be put on coils. Here in our climates here in the USA, we have whether it's a dry climate or a wet or a humid climate, more so a northern application for the northern part of the USA is that they just use air, and because it's not wet, everything is dry, and they get a film on the back of the coil, so they can vacuum it off. But once you start getting into the bigger coils that are thicker and that you're doing measurements on them, it can be a little bit more, I'd say, intense on cleaning, because you can use chemicals that are based off of alkaline coil cleaners, all the way to that are very caustic, to things that are very pH neutral, like probiotics. And then you could use hot water, warm water, a pressure washer, a hose, a pump sprayer. So you have to, it's not what's the best means. It's more so evaluating the condition of the coil before you determine how to clean it.
Okay, Paul, can we take another question? We have some people raised their hands. We'll start with Hiba Majdi. If Hiba is available, you can ask your question, Hiba. Hiba, do you want to ask a question? Okay, we have Osama. Osama has raised his hand since the beginning of the presentation. Mr. Osama, do you have a question, Mr. Osama Hassan?
I want to.
Oh, Hiba's there. Okay, let's take Hiba first. Go ahead, Hiba.
Thanks. I want to ask, as NAD standards discussed many things, but I can't find educational building. It included under other category, or it's not discussed in NDA?
I need you to repeat that one more time, Hiba. Apologies.
Hiba, can you repeat your question slowly, Hiba? Maybe the line, because of the internet, it got interrupted. Hiba, are you still with us?
مهندس رامي هي كتبته على الكيو&اي.
Many building types, but I can find educational building. Is it included?
Okay, Hiba, I think your sound is interrupted. Is not clear, but she has her question written here. as NADCA standards discussed many building types. Okay, she can't find educational building category. Is it include under the other categories? She mean that is there any special procedures for different kind of buildings?
Right, and she was referring to like education specifically.
Yes.
So under NADCA, it'll be found under commercial buildings. Okay, so it is separated by commercial buildings, residential buildings, and industrial buildings as well. So I would focus more on the commercial side of components and cleaning, and that should help answer your questions.
You can take the other questions. We have another 15 minutes more to fulfill the questions. It's good that you finish early, Mr. Paul. It seems we have a good.
Yes,
good
I'm going. What is the recommended?
Amjad Tabakh. Can you go through Mr. Amjad's question?
Yes, we're Ahmed. Okay. Hello, sir.
Amjad.
Sorry to not have.
Use filter.
Okay. How does the airflow velocity of an AC application procedure will be benefit against dust when it's less than 30 inches a minute for heat exchanger and eyes comfort? How or in what reference do we control of airflow using damper actuator and differential pressure switch? Sorry, I'm just trying to understand how I'm going to dissect it. It might be a two-part question here.
Paul, the first question is asking you whether the airflow is helping in removing or reducing the amount of duct and the amount of dust in the duct. I mean, if we increase the velocity or increase the amount of air or whatever, does this help?
Okay, yes, it does. So to understand, to explain it, is that air conditioning systems lose efficiency over time. So if it's a variable speed system, as it ramps up, anything that's loose, absolutely, it'll go through the system and then end up into the conditioned space. You're going to end up with some accumulation that never leaves the duct system, just because of its reduction in what it loses over time. But if you have a high velocity and almost nothing to catch it, then yes, you are going to experience those things as dampers open and close and send air to different areas. So I guess in reference to, do we control airflow using damper actuators or differential pressure switches? You know, again, it's going to be part of the cleaning process and the system design. So if it's designed to work a specific way, and there's continual problems, then there might need to be a new system design to effectively get it to stop putting contaminants back into the air.
Mr. Paul, he stated also like the velocity of 30 inches per minute for the heat exchanger. Would that velocity of 30 inches per minute would be beneficial to reduce the amount of dust accumulated on the heat exchanger?
As long as it's within the system's operating, you know, as long as it's within the standard of the operation of the equipment, then yes. But if you're starting to exceed what the system is supposed to be doing, as far as the 30 inches per minute, then no, and these things may need to be accounted for in different levels of filtration.
Okay, Paul, we have another question from Mr. Amjad. He's asking you about the filters. When we use filters in the airstream, it's supposed to reduce particles accumulated in the coil. What is the typical period of replacement the air filter, and especially the HEPA ones? He's asking you about the period of replacement of the filter. You can explain it to him.
Right. Yes, and then this is more so, is he asking for residential style systems or commercial style?
Sorry, Paul?
Yes, can you hear me?
Yes, yes, I can hear you.
Okay. So for residential style, you know, I would look to change a filter once every 1 month to 3 months. Okay. As far as the HEPA, the high efficiency filter, about every 6 months to a year, but that's also based off of what kind of air handling unit they're using. So these things, somebody that has a lot of turnover or a lot of trafficking in and out of a property, they may need to replace it more frequently. So these things are adjusted. The recommendation is about 1 to 3 months, you know, as far as a normal filter goes. A high efficiency filter, it can go a lot longer as long as the system is functioning properly, about every 6 months to a year.
Okay, we have a question from Engineer Iyad Abdelhadi. He's asking you, for residential applications, normally we have only supply duct with the free return. He's talking about some sample projects in Jordan actually. What measure you recommend to adopt to ensure good quality of air? I think that kind of ducting, only supply with a free return.
Right. So so you can clean the system as it sits, right? And I know where you're going with this. There's some discussion here we have right now going on about this. So if you clean the air handling unit and then you clean the supply duct, but nothing else is cleaned in the property, you've increased the efficiency of that system. So when you turn that system back on, everything that's loose that can be picked up with pressure is going to go right up into that filter almost immediately within that area. So a good practice would be able to clean most of, if not all of, the free return or the false ceiling area prior to recommissioning and starting that system again. So if you're trying to clean it for the particulate that's there, then there's a full cleaning that needs to take place in the conditioned space. So think of it in that regard when you're addressing false ceilings or open air return plenums.
Great, Paul. We have 2 more questions, I guess, or 3 more questions. We have Engineer Ibrahim Tweri. Okay, he's asking you, after how many years the ducts should be replaced?
It's not based on how many years. It's based off of what kind of condition it is in when you go look at it. So if it's wet, if it's become very wet and saturated, and it's made out of fiberglass and insulation, it's compromised. It needs to be replaced. If it's metal and it's rusting and falling apart, it absolutely needs to be replaced. And so, you know, these things, it's in relation to the condition. I'll go back to what I said at the beginning. It's in relation to the condition that the duct is in when you first show up to look at it.
Okay, Paul, we have here last question from Mr. Zaid. Mr. Zaid is asking you whether doing a sample, let's say a swab from the duct after it's been cleaned, is taking a swab also helps in making sure that the duct is clean. Especially, I think, Mr. Zaid, we use the swabs when you are detecting some kind of molds and bacteria and viruses inside the duct. Go ahead, Mr. Paul.
So you can do that. That is it's not. I can tell you that that's not something I would recommend. We do have a standard that is within the. We do have within the NADCA standard, the ACR, a NADCA vacuum test. Okay, and it shows proper procedures within the cassette of being able to utilize a vacuum to pull surface contaminants to be sent to a lab to determine the cleanliness level, and determining whether or not you should actually have to do a cleaning that way, or if it's clean to the NADCA standard. Now, I will say that is the prominent way, that is the way it is 99% of the way done over here. The other 1% of the time, people do go in and they do take swab samples of the surface, and they send in for a culture reading to be able to see what kind of airborne particulate they have or microbial growth is there, for what kinds of molds are currently in the system. So those things do take place, especially when HVAC cleaning was not part of the original scope of work, and they want to make sure that they have cleaned everything properly. So that is a way to go about doing it. But normally when you do that, as you know, in the field of study and work that you guys are in, that's opening Pandora's box. So be prepared. I think you're on mute.
Okay, anybody want to ask the last question before we wrap up this meeting? Somebody raised his hand, but his name is like, can you ask your question?
Which one is it?
It's my name actually, but somebody has got the link on my name. Anybody want to ask a question? Mr. Raed Khawad, Raed, can you talk please? This is the last question. Mr. Raed, go ahead. Please unmute yourself. Mr. Raed, go ahead.
What kind of cleaners? There is any special material of cleaner, chemical or solution, make a solution from the shops? Just it.
From what? I'm sorry, is there any kind of material?
If there is any special chemicals that could be used for cleanings of duct, coils, whatever?
Yes, and so within, and to do it safely on a cleaning, I'm going to refer you back to NADCA's website in the search portal. We have a white paper that shows the proper types of chemicals that you should be using or should not be using. It explains things that you should be aware of when picking a chemical. I don't have specific ones that I always say, oh, I have to use this one all the time. I use a variety. And so obviously the market is changing. Disinfectants, fungostats, bacteriostats, those things are emerging on a different level and scale. And we do watch what we put into systems. So I can tell you, I'm more than happy to maybe put something together in that regard, but you won't hear me tell you, oh, I want to use this chemical all the time, or I want to use this chemical and say Triple D or Envirocon or Oxine. Those types of chemicals may not be always what I'd use in a job, even though those are very common ones. Does that make sense?
Yes, Paul. Okay, thank you very much, Mr. Paul. We are really very happy and very glad to have you here on board with us in this conference. And we would like really to thank Judy from NADCA for proposing you as a speaker. We would like really to extend our thanks to you again. And also we want to extend our cooperation in the coming phases of the conference. Our conference is on phases, like every year we do one round. Round 3 will be hopefully in the next year, maybe May or June. We'll decide that. And we will be really more than glad to extend or expand the cooperation with NADCA for the benefit of the community and the indoor air quality industry. Thank you, Mr. Paul, and thanks for everyone who attended the seminar. And thank you to everyone who asked the questions. That really makes the time beneficial for everyone. We hope to see you, Mr. Paul, again with us in the coming years. Thank you very much, and please, we have a break now for 1 hour, and we will be back on 4 p.m. Jordan time, with a presentation with Dr. Shada Amura. She will talk about the ASHRAE standard 62.1, especially the ventilation rate procedure for the indoor air quality minimum ventilation rates. Thank you very much, and we hope to see you after 1 hour exactly. Thank you, Paul.
Thank you.
طيب خلينا نبلش. يلا يعطيكم العافية جميعا. مساكم خير. طبعا بنرحب فيكم اليوم معنا بالمحاضرة رقم 3 من مؤتمرنا اللي هو الثاني لجودة الهواء والبيئة الصحية الداخلية والصحة والسلامة المهنية. اليوم معنا محاضرة جدا مهمة. طبعا المحاضرة مع الدكتورة شعبة عمورة. المحاضرة بعنوان Ventilation Rate Procedure، يعني طريقة حسابات معدلات التهوية للحصول على جودة هواء داخلي حسب معيار ASHRAE ستاندرد رقم 62.1. الدكتورة طبعا شعبة عمورة معنا في هذه المحاضرة. هي رئيسة قسم الهندسة الميكانيكية في جامعة فيلادلفيا، والدكتورة حاصلة على شهادة الدكتوراه طبعا من بريطانيا، وعندها كثير من الأبحاث العلمية طبعا والمتخصصة بالذات كمان في مجال طبعا غير الاندور اير كواليتي، في مجال برضه اللي هي الانسز وحسابات الفاينايت اليمنت وعمليات السيميوليشن والموديلنج داخل المباني. هذا خيط من فيض. طبعا اللي بيحب يتعرف على الدكتورة أكثر نشرتها طبعا التعريفية موجودة على موقع المؤتمر وعلى الصفحات، ولها موقع طبعا على جامعة فيلادلفيا. اللي بيحب يفوت بيشوف الأبحاث اللي عملتها الدكتورة كمان متوفرة. معك دكتورة المايك، تفضلي بالمحاضرة، وراح نخلي للجميع الأسئلة إن شاء الله خلال آخر ربع ساعة تقريبا أو ثلث ساعة من المحاضرة. اللي بيحب عنده سؤال يكتب لنا سؤاله على الكويشن انسر اللي تحت، وإذا في مجال نسمح للناس تسأل الأسئلة بشكل علني إذا صار في مجال معنا. تفضلي دكتورة ويعطيك ألف عافية وشكرا لحضورك. عرفينا عن نفسك قليلا سريعا ونبلشي بالمحاضرة. تفضل.
الله يعطيك العافية رامي، أنت يعني كفيت ووفيت وعرفت بما فيه الكفاية. دكتورة شعبة عمورة من جامعة فيلادلفيا. حاليا أنا رئيس قسم الهندسة الميكانيكية في جامعة فيلادلفيا، وحصلت على شهادة الدكتوراه من بريطانيا بال2005. ويعني في عنا الحمد لله انترست كويس في موضوع المؤتمر، ورامي مشكورا يعني لما شفناه وقابلناه ودعانا على المؤتمر، ويعني إن شاء الله إنه بيكون في تعاون كويس بيننا وبين النقابة وبين جميع المشتركين. اوكي خليني ابلش. اليوم مش عارفه اللغه اللي بدكم اياها، انجليزي عربي، ايش اللي بتفضلوه؟
بدك اياها دكتوره احكي، اذا بدك عربي ولو السلايد بالانجليزي، اذا بتحكيها بالعربي كويس.
طيب اوكي ما في مشكله، راح احكي باللغتين. طيب اليوم رح نحكي عن الASHRAE standard 62.1 و precisely about ventilation rate procedure. Okay, ASHRAE standard 62, it has many sections, and one of the sections is the procedure. So today we don't have enough time to cover the whole procedure 62.1, so I'm going to emphasize on the ventilation rate procedure. So introducing the ASHRAE standard 62.1.2. Okay, this is one of the objectives. Then explaining the ventilation related procedures, some sections that you can go and read it just by yourself, also you can take a course. I advise you to take a course with Rami about the other sections. So he's going to explain it in a good way for you. Now, as a background, all of us know that we have the COVID-19. And earlier in the morning, people were talking about COVID-19 and how to come back again from this pandemic and work in the buildings. So we need a good atmosphere. We need a healthy indoor air quality. So this is to stop the virus from spreading, and also for us to maintain good health. And all of us know that if our work environment is not good enough or not healthy enough, all of us will feel dizzy, will feel uncomfortable. We have low production rate, we have low motivation to go to the work. So everybody desires a good and healthy environment to work in, and that's why ASHRAE 62.1 is to ensure acceptable indoor air quality through good ventilation. Well, ASHRAE, I'm going to give you just a brief history about ASHRAE 62.1. The latest version is in 2010, Okay, this is the latest edition, which has made some modification to 62.1 in 2007. Okay, with the 80 approved addenda to 2007 edition. The earliest one, or the first edition, was in 1973 as ASHRAE 62. Then definitely, as time goes on, some key changes have been made until we reach the last edition in 2010, and it's no longer applied to smoking areas. So ASHRAE 2010 is not applied to smoking areas. This is because simply it doesn't go with the scope of the standard, because we're talking about good indoor air quality. So smoking definitely is not a good indoor air quality. It doesn't give us the scope of this. So no more about smoking areas. And it talks also about natural ventilation has been relocated in the code again. Okay, and ASHRAE 62.1 forward addresses the major changes to 207 in its addenda and its appendixes. If you go and download the standards from the net or from any other source, you can find the changes that have been made to ASHRAE 2007 if you already have this edition. Okay, let's go quickly through the contents of ASHRAE 62.1. The first section.
معلش بدنا نقطعك شوي، في عندنا مطالبات بانه تحكي باللغه العربيه، لانه معظم الحضور عندنا يعني من اللوكال. فاذا بس بتحكي بالعربي بيكون الفكره واصله اكثر شوي.
خلاص اوكي، خلاص ما في مشكله. اوكي ماشي الحال. سكشن 1 اللي هو بيحكي عن اهداف الكود تبعنا اللي هو purpose of the standard. سكشن 2 بيحكي عن الستاندرد سكوب اللي رح نحكي عليها. definitions التعريفات رح تلاقوها موجوده بسكشن 3. سكشن 4 بيحكي عن الاوتدور اير كواليتي اللي هو الهواء اللي احنا رح نسحبه للتهويه من الخارج. ماشي. وسكشن 5 بيحكي عن السيستمز والاكويبمنتس. وسكشن 6 بيحكي عن البروسيجرز اللي رح نتكلم عنها اليوم، بالاخص عن الفنتيليشن اير بروسيجر. اوكي. وسكشن 7 بيحكي عن كونستراكشن والسيستم ستارت ابس. اخر شيء في عندنا سكشن 8 اللي هو الاوبريشن اند مينتننس. اوكي. احنا رح يكون الامفاسايز تبعنا مينلي ما بين 4 و6 بيسكلي اللي هو الفنتيليشن ريت بروسيجر. هلا خلينا ناخذ كويك لوك على السكوب للاشري ستاندرد 62. ماشي، يعني ما راح ارجع اقراهم كلياتهم جست مجرد قراءه، فانا راح احكي لكم اياهم بشكل عام جنرالي، وراح نركز على بعض النقاط الموجوده عندنا هون في السكوب. طبعا ديفينتلي هو ابلاي لكل انواع الاكتيفيتيز، يعني مثلا للجيمات، للمسابح، للمصانع، خلينا نحكي المكاتب الكبيره، المولات، يعني كل انواع الاكتيفيتيز اللي هي فور هيومن اوكيبنسي. ماشي، اللي موجودين فيها الناس باختلاف اللي هي الديجري اوف اكتيفيتي لهم، نوع الحركه الموجوده موجود فيها، نوع الابلكيشن، كلياته هذا الكود انت بتقدر تشتغل عليه وتحسب، تعمل حسابات اللي هو الفنتيليشن بناء على اساسه. طبعا احنا استثنينا في البدايه ايش؟ استثنينا في البدايه اللي هي السموكينج ارياز. طبعا هون في عندكم كمان اللي هو الهاوسز اللي بيوتنا احنا الناس بنعيش فيها، بالاضافه لبعض الاماكن الصغيره. طبعا هذه يعني صعب اجي اقول والله انا شقه 200 متر ولا وات ايفر انا بدي اطبق عليها الاشري كود لما اعمرها. انت حر في بيتك شو بدك تساوي، يعني توتالي ديفرنت سيناريو، يعني ما يعني ممكن انت تطبقه ممكن لا، بس هو مش within السكوب تبع هذا الستاندرد. حنحكي على ابلكيشنز كبيره شوي. طبعا داخل هذا الستاندرد زي مثل ما استعرضنا احنا في الكونتنت، فهو بيعطينا requirements for ventilation, air cleaning, system design, installation، كل اللي هي الاشياء المتعلقه بالنظام الميكانيكي، اوكي، اللي انت بدك تحطه وتحصل منه عمليه التهويه الميكانيكيه، او اذا كانت برضه كمان combined مع عمليه التهويه الطبيعيه من خلال الناتشرال فنتيليشن. ماشي. طبعا هون بيحكي لك additional requirements laboratories, industrial healthcare, other spaces، برضه هاي كمان included موجودة عندنا. اوكي. ولك although the standard may be applied to both new and existing buildings، يعني كمان يطبق على الأبنية اللي قيد الإنشاء والأبنية اللي هي already منشأة، واللي هي بسموها موجودة عندنا في علم الاندور اير كواليتي السورس elimination وموديفيكيشن. elimination أنا من الديزاين من البداية بحاول إنه نعمل المبنى تبعنا بحيث إنه لما يجوا الناس يتواجدوا فيه ويمارسوا نشاطاتهم فيه يكون من البداية سليم. موديفيكيشن أنا ممكن عندنا مبنى مريض سك بيلدينج زي ما تطرق زميلنا في البدايه لما شرح عن الكلينينج وحكى كيف انه احيانا عدم التنظيف بسبب سك بيلدينج، احنا ممكن نيجي نفحص هذا المبنى ونطبق عليه الكود بحيث انه نحصل بالاخر تعديل واضح على جوده الهواء الموجوده عندنا في الداخل. اوكي، هلا هون بحكي لك this code ضمن الاشياء اللي الواحد لازم يعرفها doesn't prescribe a specific ventilation rate requirement for spaces that contain smoking، وهي already حكينا عنها في البدايه. بعدين اللي هو كمان بالسكوب 6 ventilation requirement of this standard are based on، هاي شغله كثير ضروريه تكون نعرفها، اللي هي الكيميكال والفيزيكال والبيولوجيكال contaminants that can affect air quality، يعني اللي هي النواحي الكيميائيه معروفه، الملوثات مثل ثاني اكسيد الكربون، الامونيا، الاسيتون، الفورمالديهايد، هاي انواع الملوثات الكيميائيه. الفيزيكال اللي هي العضويه نتيجه الحركه الليفل اوف اكتيفيتي الموجوده. البيولوجيكال مثل الفطر والعفن، الفيروسات، البكتيريا، الاشياء اللي ممكن انها تنزل عندي جوده الهواء في المكان اللي احنا رح نشتغل عليه. اوكي، برضه كمان موضوع الكنترول للثيرمال كومفورت برضه كثير كمان مهم، لكنه مش داخل عندي وذن هذا الكود، لانه اوريدي في عندنا اشري ستاندردز بتحكي عن الثيرمال كومفورت اللي هم الستاندرد ال 52 وال 55، هم عندهم علاقه اكثر في موضوع الثيرمال كومفورت من خلال considerations ثانيه مختلفه، فما رح نتكلم عنه وذن هذا الستاندرد. اوكي، هلا كمان بقول لك the standard contains requirement in addition to ventilation related to certain sources including outdoor air. بحكي لنا عن الاوتدور air quality، لانه طبعا اكيد انت بدك تسحب هواء من برا مشان تعمل ventilation، فضروري تطلع كمان على الاوتدور air quality. هاي برضه في لها tables موجوده عندنا within هذا الستاندرد. هلا طبعا هون اخر شيء هم حاطينها از ناحيه، يعني خلينا نقول نقطة لو ما تحققت عندنا احنا الاندور اير كواليتي بناء على الحسابات تبعتنا، ممكن يكون في عندي اسباب من ضمنها اللي هو اختلاف انواع الكونتامينانتس. ممكن يكون عندي مجموعة كبيرة من الكونتامينانتس صعب السيطرة عليها، هاي من ضمن الاسباب اللي ممكن احنا تاثر عنا على حساباتنا للاندور اير كواليتي. كمان من ضمن الفاكتورز اللي هي خلينا نحكي التمبريتشر sometimes بتكون مش uniform within السبيس اللي احنا رح نشتغل عليه، الهيوميديتي، النويز، اللايتنينج، السايكولوجيكال ستريسز، هاي كلها sometimes اذا كانت كثير دايفيرس كثير متنوعه within the space sometimes ممكن احنا تاثر عندي وما بتعطيني الجوده اللي احنا بدنا اياها. فيعني عشان ما تلوم الستاندرد، فبحكوا لك انه هاي قد تكون احد الاسباب اللي بتسبب المشاكل اللي ممكن ينتج عنها انه ما نحصل الاندور اللي بدنا اياها. اوكي، برضه كمان اللي هو موضوع اللي هو التنبؤ، عدم الرضا، يعني في عندنا امور ثانيه كثيره موجوده ممكن تنزل عندي اللي هو الاندور اير كواليتي او ما توصل خلينا نحكي للاكسبكتيشنز المطلوب منه. طيب هلا سكشن 3 وهون يعني بيجي عندنا بنبدا في الاهم. ماشي، سكشن 3 اللي هو بعطينا الديفينيشنز، فانت ما تفوت على الستاندرد تقراه وتتصفحه. ماشي، راح يكون في عندك بسكشن 3 اللي هم الترمينولوجيز المستخدمه والتعريفات. ماشي، فهلا من ضمن التعريفات الموجوده عندنا هي اول تعريف، اهم تعريف انا بشوفه اللي هو تعريف الاكسبتبل اير كواليتي. ايش يعني acceptable air quality؟ متى انا بعتبر الاير كواليتي تبعتي accepted؟ ماشي، فحطت اشري لها تعريف راح اقرا لكم اياه بعدين راح اشرحه، اللي هي air in which there are no known contaminant at harmful concentration as determined by cognizant authorities and 80% satisfaction of the occupants. اللي هي ما في عندنا احنا بتعرف عندنا احنا اللي هي وزارة الصحة والمنظمات البيئية بتعطينا التراكيز الموجودة في الهواء، قديش مسموح فيها، خلينا نقول الليمت تبعتها مثلا قديش لازم ثاني اكسيد الكربون، قديش النسبة المينيموم اللي لازم يكون متوفر فيها بحيث انه اعتبره اوكي. ماشي الحال، الدست غيره يعني بتعطيك انت قديش اللي هي خلينا نقول التراكيز اللي لو وجدت في المكان هذا انت ستيل بالسيف سايد. ماشي، يعني لا يمكن ابدا انه ما يكونش عندي ثاني اكسيد الكربون زيرو، لا يمكن ابدا بعض الكونتامينانتس تكون زيرو، بس موجوده التراكيز ما بتضرنا ما بتاثر على صحتنا. اوكي، فاذا هي موجوده وذن التراكيز المسموح فيها ماشي، فبالتالي اوكي، والناس الموجودين 80% من الاوكيوبنتس اللي هم العالم الموجودين في السبيس تبعنا ساتيسفايد، واضح؟ فبالتالي انا بقدر احكي انه انا في عندي acceptable air quality. ماشي الحال؟ وطبعا بالنسبه لنسبه الرضا في عندنا شيء اسمه البريدكتد مين فوت اللي هي من خلال استبيان من خلال فحوصات معينه، في سنسورات كثيره، في وسائل كثيره لقياس الامور هاي كلياتها، فبنعمل سيرفي عن المبنى، فبينعرف بالنهايه نسبه الساتسفاكشن من خلال قياس اللي هي موضوع الكونسنتريشنز قديش موجوده، والاوكيبنتس مدى رضاهم برضه كمان، وبالنهايه بنطلع بكونكلوجن هل هذا المبنى خلينا نحكي انه في فعليا في اكسبتبل اير كواليتي او لا. هلا من التعريفات المهمه كمان البريذنج زون. البريذنج زون هاي رح نشتغل عليها later on لما نحكي عن البروسيجر، فاللي هي بعرف لك اياها انه the region within an occupied space between planes 3 and 72 inches، اوكي، اللي هي تقارب 75 و 1800 ملم above the floor، اوكي، and more than 2 feet from the wall or fixed air conditioning unit. لو جينا طلعنا احنا هون ماشي الحال، في عندنا هذا الاطار، هذا طبعا الصوره برضه كمان انا اخذتها من الكود الموجود عندنا، موجوده هاي الرسمه اللي هي فيجر 6A موجوده within الكود، ماشي. ففي عندنا هذا الاطار الكامل الموجود هون هياته الاسود الكبير، هذا الاوكيبايد سبيس. بس احنا فعليا رح نحكي عن البريذنج زون اللي هي جزء من الاوكيبايد سبيس اللي ابعادها معرفه عندنا هون كالاتي، يعني بتطلع من الارض بارتفاع 3 انش، اوكي صغيره، بعدين فوقيها بتطلع فوق 72 انش، بعدين اللي هي 24 انش بعيد عن الوولز، وبتحصرها بهذا اللي هم الداش بوينتس الموجودين، اوكي عندنا هون. فبالتالي هاي هي بنسميها البريذنج زون، واللي هي اغلب الشغل رح يكون عليها، ماشي الحال. فيعني انت ما رح تشتغل على كل الاوكيبايد سبيس، احنا رح نشتغل على ما يسمى في البريذنج زون. هاي برضه من ضمن التعريفات المهمه الواحد يعرفها، اوكي. هلا خلينا ننزل على هاي الرسمه، ماشي. هلا الرسمه هاي موجوده عندنا هون داخل هاي الرسمه، اوكي. في عندي انا اللي هو خلينا نحكي الاوكيبايد سبيس كامل، ماشي الحال. هو السكيماتيك بورجينا وكمان كيف بتصمم الميكانيكال سيستم بحيث تعطيني الانلت والاوتلت على الاوكيبايد سبيس، اوكي. فلو جينا طلعنا هون، هاي في عندي هون السبلاي اير اللي داخل عندي على السبيس، هياته موجود هون بالسهم واضح، هياته هذا السبلاي اير، اوكي، اللي هو الهواء اللي احنا اخذناه من الاير كونديشننج يونت، ماشي. هاي الاير كونديشننج يونت بعد ما بتعمل عليه عمليه الهيتنج والكولينج، الهيوميديفيكيشن اور دي هيوميديفيكيشن، فهياته هذا السبلاي اير داخل عندي، اوكي. هلا برضه من الاوكيبايد سبيس ممكن يكون هذا الاوكيبايد سبيس از فويد، ممكن يكون مول، ممكن يكون مستشفى. طبعا السبلاي اير لما انت عندك يفوت بتوزع من خلال الدكتات ومن خلال اللي هي خلينا نقول الاير ديستريبيوشن سيستم على كلياته. بالنهايه في عندنا الريتيرن اير، الريتيرن اير اللي هو طالع او راجع من الاوكيبايد سبيس. هلا الريتيرن اير هذا جزء منه، اوكي، بروح اوكسوست، وجزء منه بروح ريسيركيوليتد بنسميه، اللي هو يعاد تدويره، ماشي. هلا الريسيركيوليتد اير هذا لما يعاد تدويره، اوكي، طبعا لازم يمر عبر فلاتر، راح ياخذ مجرى بحيث انه يتم عمليه الاختلاط عند شيء بنسميه اللي هو الانرجي ريكفري فنتيليشن سيستم، او بنسميها الميكسنج تشامبر. في عندنا ندخل عندنا الميك اب اير او الاوت دور اير، طبعا في عندك حاط لك لوكيشن لكلينر في حال انه كان الهواء اللي جاي من برا بده تنظيف من دست من غيره، من اللي بيكون فيه فلتر، ماشي. فبتصير عندنا عمليه الميكسينج ما بين الستريم اللي راجع من الاوكيبايد سبيس والستريم الهواء اللي داخل عندي من برا. الهدف من هاي العمليه او ليش اسمها انرجي ريكفري، لانه فعليا لما يصير ميكسينج هون بين تو ادياباتيك اير ستريمز، انت الهواء اللي جاي من الاوكيبايد سبيس هو له نفس الخواص الحراريه اللي انت صممتها في الاير كونديشننج يونت. طبعا في لوسز اكيد، يعني لو كان مثلا خلينا نحكي الاوبريتنج تمبريتشر او درجه الحراره التصميميه على سبيل المثال 25 سلسيوس، اوكي، وتوزعت عندي على المبنى ورجعت فيها ريتيرن، اوكي، وطبعا رح يكون في عندنا فواقد حراريه، يا كسب حراري بالصيف او خساره حراريه في الشتاء، اكيد في عزل بس ما في كفاءه 100% للعزل. فبالتالي على ناخذ انها الدنيا صيف رح تختلط بتيار للهواء خلينا نقول درجه حرارته 35، فالناتج اللي طالع رح يكون درجه حراره شو مالها اعلى من ال 25 واقل من ال 35. فلما تفوت على الاير كونديشننج يونت، اكيد انت لما بدك تعمل اير كونديشننج او تبرد هواء، خليني احكي مثلا درجه حرارته 27 او 28، مش زي الانرجي اللي رح تصرفها على تبريد هواء درجه حرارته 35 او 40 جاي من الاوت دور، اوكي. فيعني هاي من ضمن الاهداف انه احنا بنسحب ريتيرن نعمل له ريسيركيوليشن. الهدف منه انه انت شو تنزل الكونسمبشن على وحده التكييف المركزيه اللي راح تعطيك السبلاي اير ليتر اون. اوكي. هلا اذا طلعنا على الاوكيبايد سبيس نفسه ماشي، في عندي انفلتريشن داخل عندي لجوا، وفي عندي اكسفلتريشن شو معناه؟ طالع لبرا. فالانفلتريشن اللي هي التسريب، احنا بنسميه بالعربي التسريب، اللي هي الهواء اللي بدخل عندي من الشقوق ومن النوافذ، من يعني اي شيء من تحت الابواب. اوكي. هاي كلياتها حسب طبعا البريشر ديفرنس، لما يكون الضغط الخارجي اعلى من الضغط الداخلي فراح يصير عندي التسريب اللي هو الانفلتريشن. برضه هذا بده ينضاف على الحمل هون، واحيانا كمان هذا بيحمل لي اذا كان الهواء الخارجي فيه كونتامينانتس، ثاني اكسيد كربون، فيه داست، فيه وات ايفر، راح يدخل لي اياها على السبيس. فيعني الانفلتريشن من ضمن الاشياء اللي الواحد لازم يعالجها داخل الاوكيبايد سبيس تبعه. والاكسفلتريشن هو عكس الانفلتريشن، في حال انه شو؟ انه انا في عندي تسريب من الداخل للخارج، برضه كمان كله بيعتمد على فروقات الضغط. اوكي. يعني هذه برضه خساره احنا بنعتبره الاكسفلتريشن. هاي برضه من الترمينولوجيز المهم الواحد يعرفها. هلا في اللوكال فنتيليشن، انه احيانا بعض الاماكن انت بدك بالاضافه للفنتيليشن الهواء اللي انت سحبته من برا ودخلته ميكانيكالي على السبلاي اير، في بعض المناطق within الاوكيبايد سبيس بتحتاج لكمان لوكال فنتيليشن. اوكي. لتهويه زياده، تبقى سبيشال بيربوسز او اماكن معينه فيها سبيشال نيد. فهي محطوط عندك مثلا الكلين اوكي اير، هياته داخل ميك اب اير، برضه لوكال ميك اب اير سميناها، الجاي من برا للوحده كامله اسمه الاوت دور ميك اب اير. اللوكال هذا اللي هو تبع اللوكال فنتيليشن. ونفس الشيء زي ما في عندي انبوت في عندي اوتبوت مشان موضوع الماس بالانس داخل الاوكيبايد سبيس. ماشي. هلا نيجي على ستاندرد 4. اوكي سوري سكشن 4 من الستاندرد تبعنا اللي هو بيحكي عن الاوت دور اير كواليتي. زي اللي كتبتوا هون سوري الدياجرام اللي شفتوه هون، احنا بنسحب اوت دور اير مشان عمليات التهويه. حتى في الناتشرال فنتيليشن انت بتفتح الشبابيك عندك، تفتح الشبابيك تقول والله في ريحه مو حلوه، مسكروا الشبابيك ماشي، ولعوا المروحه. اذا احنا شو اغلقنا التهويه الطبيعيه ولجأنا للتهويه الميكانيكيه، ولع الاي سي، في غبره، في حوالينا مبنى. فبالتالي سكشن 4 رح يعطينا اللي هي كيف احنا رح نحكم على جوده الهواء الخارجي اللي جاي عندي من برا. ماشي. واللي هي mainly في السراوندينجز حول المبنى تبعنا. اوكي. هلا في بامريكا اللي هي الناشونال امبيانت اير كواليتي ستاندردز تبع جمعيه حمايه البيئه او جمعيه البيئه. اوكي. هم mainly المعنيين، واحنا عندنا اياها موجوده هذه، المعنيين والمسؤولين عن دراسه الملوثات الموجوده، خلينا نحكي في الفار فيلدز، في الهواء، في الاماكن اللي احنا بنعيش فيها. اوكي. مثلا من الاخطاء الموجوده عندنا في الاردن وبشده، اذا في حد سكان الزرقاء ما يزعلش، السكنه حول المحطه. هاي يعني كارثه للاسف الشديد. استاديوم الرياضه قبال محطه الحسين الحراريه، طب كيف هذا الحكي؟ منطقه ملوثه هذه، خصوصا انه حتى التشيمينيز تبعتهم والستاكس تبعتهم اللي طالعه لفوق حتى مش طالعه بالارتفاع المناسب. فبالتالي اذا بدنا نيجي نفحص جوده الهواء هناك، اكيد الناتشرال فنتيليشن انا راح اكنسل عليه. اوكي. فبالتالي راح يعطيني نسبه تركيز ثاني اكسيد الكربون، نسبه هذه كلياتها مين؟ اللي هي الجمعيه المخصوصه في هذا الكلام، اللي هي الجمعيه الامريكيه اللي هي الناشونال امبيانت اير كواليتي ستاندردز. هلا في تصنيف ثاني اللي هو الاتينمنت او نون اتينمنت. اوكي. هذا الحكي كلياته بيعتمد بناء على الجدول الموجود عندنا هون اللي هو 4A اللي بتعطيك التراكيز للملوثات المعروفه. طبعا في ملوثات ثانيه موجوده حسب المكان والبيئه اللي احنا بنعيش فيها. اوكي. اللي هي حسب مثلا عندك البرايمري ستاندردز، السكندري ستاندردز، تعطينا الافريج تايمز اللي هي قديش معدل وجودها داخل الهواء. اوكي. هاي كلياتها محسوبه من خلال تراكيز معينه، من خلال دراسات معينه، واتيها بناء على اساس هذا الكلام انت بتختار الفلتر المناسب للملوثات الموجوده عندك في المنطقه. لانه انا ما بدي اسحب اوت دور اير ويطلع نفس الاوت دور اير ملوث. طب انا شو استفدت من الفنتيليشن؟ شو استفدت؟ معناته انا سحبت الملوثات اللي برا حطيتها جوا. فإذا ضروري إنه إحنا نعرف قديش نسبة التلوث الموجود عندي الخارجي to deal with it، بحيث إنه لما أسحب أنا هواء من برا، وضروري نسحب هواء من برا مشان السايكل تبعتنا تكمل، فبالتالي نعرف كيف بدنا نتعامل معه للأوتدور اير كواليتي مشان أضمن الإندور اير كواليتي. أوكي؟ هلا سكشن 5 احنا ما حكيتش عنه كثير. سكشن 5 من اللي بيحكي عن الايكويبمنتس، اوكي، وبيحكي عن الكلاسيفيكيشنز للهواء، بيحكي عن اشياء كثيره. انا اخترت منه سكشن اللي هو 5/16 اللي بيحكي عن الاير كلاسيفيكيشن اند ريسيركيوليشن، لانه هذا رح يهمنا في الحديث عن الفنتيليشن ريت بروسيجر اللي رح نيجي عليه هلا. اوكي، فالاير كلاسيفيكيشن خليني ارجع فيكم اذكركم في الرسمه مره ثانيه. هاي الرسمه تبعتنا الموجوده هون. الريتيرن اير قلنا جزء كبير منه بيروح لريسيركيوليشن، جزء كبير doesn't mean انه كلياته، اوكي، بيروح عندي as a recirculated air للانرجي ريكفري. وحاليا معظم الانظمه الحديثه بتستخدم الريسيركيوليتد اير طبعا حسب الابلكيشن وحسب اعتبارات ثانيه كثيره. فهلا مش كل الهواء الموجود within الاوكيبايد سبيس انا بقدر اعيد تدويره، ولا كل الاماكن انا بقدر اخذ منها راجع. وللاسف في عندنا اخطاء كثير بتصير عندنا في الديزاين لانه في عدم معرفه بالاير كلاس. ماشي، ففي عندك انت هون في الكود بتعطينا مثلا تيبل 5/2 تيبل 6/1 تيبل 6/4. ماشي، هدول بيعطوك اللي هي الكلاسيفيكيشنز، تعطينا مقدار الريسيركيوليشنز. اوكي، هل المكان هذا مسموح تاخذ منه مش مسموح تاخذ منه، هاي رح ننزل عليهم بحيث انه نشوفهم. قبل هيك خلينا نحكي بس على الكلاسز بشكل سريع. الهواء مرتب كلاس 1 2 3 4. كلاس 1 اللي هو احسن واحد، ماشي، اللي هو air with low contaminant concentration, low sensory irritation، ماشي، intensity and inoffensive odors. اوكي، اللي هو يعني خلينا نقول الكلاس الراقي هذا الكويس، انا بقدر بكل سهوله من دون خوف اخذ منه راجع او اخلطه مع الباقي من دون اي مشاكل. اوكي، فهذا كلاس 1. كلاس 2 اللي هو air with moderate contaminant concentration، بيجي هذا شوي اقل درجته منه، mild، اوكي، sensory irritation، يعني في مشاكل ممكن تسبب مشاكل بالتنفس، مشاكل ممكن حكه بالعيون whatever حسب نوع الملوث الموجود، or mildly offensive odors، روائح. اوكي، هلا هم بقول لك class 2 air also includes air that is not necessarily harmful، مش ضروري يكون كثير سيء or objectionable but that is inappropriate for a transfer or recirculation to spaces used for different purposes. اوكي، يعني ممكن يكون عندي ايش ماله في يعني ممكن انا اعمل له recirculation بس بدي اكون ايش محتاط للموضوع. كيف الاحتياط الموضوع؟ بحط فلاتر، لو بدي اعمل له recirculation بحط فلاتر مشان اخلص من التلوث الموجود فيه. فضروري الواحد يعرف شو كلاس الهواء اللي بيتعامل معه. كلاس 3 اوكي بيجي اسوء من 2 اللي هو air with significant contaminant concentration, significant sensory irritation intensity or offensive odor. ماشي الحال، واضح فيه اللي هي مثلا فيه روائح واضحه مثل الحمامات، مثلا لابراتوريز، اماكن معينه مثلا فيها ابخره معينه، المطابخ اوكي اللي بتستخدم الغازز. يعني هاي الامور انت بدك تاخذ منها ريتيرن وترجع وتسحب، راح انت تخرب الدنيا يعني. فكلاس 3 مش كثير ريكومندد للريسيركيوليشن unless it is treated، يعني عالجنا الموضوع فيه. كلاس 4 اللي هو الهازاردس الهارمفul، على شيء اوكي with highly objectionable foams or gases or with potentially dangerous particles. اوكي، كلاس 4 هذا it's not recommended to recirculate at any under circumstances. مبنية. ماشي اوكي. هلا في بعض الاستثناءات بقول لك air from spaces where ATS اللي هي قلنا التعريفها اللي هي environmental tobacco smoking area. اوكي، احيانا ممكن في المطارات، احيانا ممكن في بعض المولات اللي بتحافظ على الصحه بقول لك هاي منطقه للتدخين. احنا قلنا هذا الستاندرد ما بيتعامل مع السموكينج اريا از ديزاين، بس لو وجدت السموكينج اريا هذه كانت اوريدي ذير بنعرف كيف احنا بدنا نتعامل معها. ديفينتلي هي لازم تكون نيجاتيف بريشر روم بحيث انه ما يطلعش لعندي الدخان ريحته لبرا. طبعا الدخان تبعها نو واي انه يكون ريسيركيوليتد ستريت فورورد اكزوست لبرا، ماشي الحال، والها تهويه برضه كمان من ناحيه خاصه. فيعني هاي يعني مستثنيها تماما من هاي الكلاسز، هاي هارمفول، خلص انتهى موضوعها، انا بطلعها لبرا كلياتها، فما رح نتعامل معها. لو جينا طلعنا هذا تيبل 5/2 اللي حكينا عنه، اوكي، بعطينا هون مثلا بعض الابلكيشنز او الديسكربشنز والاير كلاس لها. دايزوبرنتيك ايكويبمنت ديسشارج 4، الكوميرشال كيتشنز 4، اوكي، فيعني ممكن انه الواحد يطلع عليه ويعرف نوع الهواء اللي بيشتغل فيه. ماشي. هلا المهم عندنا هون في موضوع البروسيجرز اللي هم كيف احنا نحسب قديش بدنا ventilation rate. اوكي، قديش انا بدي نسبه تهويه، قديش CFM، اوكي، قديش كيوبيك فيت بير مينت لازم اسحب من برا، ماشي الحال، قديش انا لازم يكون في عندي لتر بير سكند حسب الوحده المستخدمه حسب الديزاين. فالفنتيليشن ريت بروسيجر mainly بيعتمد على السبيس والتايب ابلكيشن، على الاوكيوبنسي ليفل والبايو افلونس وعلى الفلور اريا. وطبعا هذا الحكي كلياته موجود بسكشن 6.2 وفي له تيبل رح نوضح عليه اكزامبل بسيط في النهايه. هلا في البروسيجر الثاني اللي هو الاندور اير كواليتي بروسيجر. الاندور اير كواليتي بروسيجر برضه كمان لحساب قديش نسبه التهويه لازم تكون at the end بالوحده المناسبه لها، لكن هون الاندور اير كواليتي بروسيجر بيعتمد اكثر على الاناليسيس of contaminant sources, contaminant concentration limits الموجوده عندي والlevel of perceived indoor air acceptability. اوكي، يعني هذا كان بيعتمد على الفلور، بيعتمد على النمبر اوف اوكيوبنتس وعلى النشاط الفيزيائي الموجود. هون لا بنركز اكثر على نوع الكونتامينانتس الموجوده، اوكي، وكيف احنا نعمل لها دايلوشن، النسب اللي اسحبها عشان نعملها دايلوشن، وبتعتمد كمان على اللي هي الاير اكسبتابيلتي. هاي بالنسبه للاندور اير كواليتي بروسيجر. في اخر بروسيجر موجود اللي هو ناتشرال فنتيليشن بروسيجر، برضه كمان موضح عندنا في سكشن 6.4. اوكي، والناتشورال فنتيليشن له برضه حساباته المتعلقه في الارتفاع وفي الابعاد، يعني احنا ما رح نحكي عنه كثير. بقول لك the perspective design procedure presented in section 6.4 in which outdoor air is provided through openings اللي هي الفتحات الموجوده، قد تكون special openings مع عليها دامبرز تفتح وبتسكر حسب حركه الهواء والضغوط ما بين داخل المبنى وخارج المبنى، او قد تكون اللي هي الشبابيك والابواب الناتشورال تبعتنا. طبعا المباني التجاريه والكبيره mainly احنا رح يكون في عندنا ميكستشر ما بين الميكانيكال اوكي والناتشورال فنتيليشن، لانه رح يكون في يعني كثير sometimes اللي هي الناتشورال فنتيليشن requirement doesn't meet في المباني الكبيره، تكون من ناحيه معماريه شويه not easy to achieve، يعني في لها كودات خاصه فيها بتدخل تحت بند الباسيف بيلدينجز in a way. طيب الفنتيليشن ريت بروسيجر تبعنا اول شغله رح نحكي فيها عن الاوتدور اير تريتمنت، اوكي، واللي احنا شرحناها لما حكينا بسكشن 4. ماشي، الهواء اللي بسحبه من برا لازم يكون تريتد حسب الكلاس تبعه، ماشي الحال. بعدين في عندي البارتيكوليت ماتر smaller than 10 مايكرومتر اللي هي PM 10. اوكي، هاي بتحكي لك on particulate matter filter of air cleaners shall have a minimum efficiency reporting value اللي هي الميرف of 6 or higher when ايش مالها rated in accordance طبعا للانسي والانشي ستاندرد 52 اللي هي بتتعامل معنا بموضوع الفلاتر. هذه بالنسبه لتنقيه الهواء اللي هي متعلقه هون في الاوتدور. واذا كانت عندي اللي هي البي ام 2.5 اوكي اللي هي particulate matter filter of air clearance لازم تكون الميرف تبعها 11 او اعلى طبعا لانها اصغر. اوكي، هاي بالنسبه لموضوع التريتمنت للهواء اللي جاي عندي من برا. برضه كمان بالنسبه للاوزون اللي هي اير كلينر، احنا ما عندناش كثير مشكله اوزون بتوقع هون في الاردن، بس يعني في لها بقول لك if ozone shall be provided when the most recent 3 years الموجوده اغلبها في امريكا هاي المشكله. اوكي، بعطيك اللي هون التركيز اللي عندنا وحده كيميائيه اللي هي 0.107 بارت بير مليون. اوكي، لما يكون يعني هذا الحد الادنى له يتجاوز انت بحاجه لتحطوا لهم طبعا الجازيوس فلترز بحيث انه نخلص من موضوع الاوزون اذا كان متواجد في الخارج عشان ما اسحبوش وادخله لجوا. وبالتالي قبل ما احنا نفوت في الحسابات بدنا نعرف كيف ننقي الهواء اللي جاي عندي من برا. هلا بالنسبه للحسابات تبعتنا، الحسابات تبعتنا في معادلات اوكي كلياتها تعطى في سكشن 6.2 اوكي والسب سكشنز له. اول شيء اللي هي قديش راح يكون عندي قديش مقدار الاوتدور اير ريكوايرد ان ذا بريذنج زون اللي ورجيناكم اياها وعرفناها في البدايه. ماشي، المعادله اللي هي 6.1 اللي هي بتعطيني انا قديش مقدار الاوتدور اير فلو ريكوايرد اللي هي الفي بي زد. ماشي، بتساوي لنا اللي هي الفي بي اللي هي on personal basis زائدا on area basis. اوكي، هلا الار بي والار اي اللي هي هذه قديش انا مقدارها اللي هي بدها تكون عندنا اياها بليتر بير بيرسون بضربها في النمبر اوف بيرسونز راح نشوفها كمان شوي في التابل زائد اللي هي الار اي اللي هي بير متر سكوير او بير اللي هي اريا. اوكي، يونت اريا مضروبه في الاريا. هاي الار بي اللي بقول لك outdoor air flow rate required per person. P Z the number of people RA اللي هي الاوتدور اير فلو ريت ريكوايرد بير يونت اريا، والاي زد اللي هي النت اوكيوبيبل اريا اوف ذا فنتيليشن زون في اما الفوت سكوير او المتر سكوير. اوكي، هاي الفاليوز كلياتها في تيبل موجود ماشي. هاي هي تيبل 6.1. اوكي، بعطيني اياه، هذا اكزامبل عليه. طبعا بدك ترجع للستاندرد تفتحه، موجود عندي التيبل بكل الكلاسيفيكيشن. التيبل اللي هو بحكي لنا في عندنا مثلا انواع الفاسيلتي، الاوكيبنسي كاتيجوري، بعطيك اياها تعريف في معظم الكاتيجوريز ماشي. في عندنا الكوركشنال فاسيلتيز، سيل، داي روم، جارد ستيشن، educational فاسيلتيز. يعني هاي بعطينا في البدايه هياته البيبل اوتدور اريا ريت الار بي اللي حكينا عنها بالسي اف ام اذا كنا نتعامل في الانجلش يونتس، او لتر بير سكند بير بيرسون. اوكي، لا اذا كنا بنحكي على الاس اي. واضح؟ بعدين في عندي الار اي اللي هي الاريا اوتدور اير ريت، هي الار اي ماشي. فحسب نوع الفاسيلتي احنا بنيجي بناخذها وبنطبقها على معادله 6.1 وبيعطينا قديش مقدار الاوتدور اير فلو. هلا في امور ثانيه كمان بالاضافه لهذا الكلام ماشي. لازم نعرف قديش مقدار الماكسيمم population. واضح؟ وهذا الحكي احنا بنقدر نحسبه من خلال معادلات رح نيجي عليها. وبرضه كمان بهمنا نعرف قديش الافكتفنس للديستريبيوشن سيستم تبعنا. احنا سحبنا الهواء من برا بدنا ناخده ونوزعه لجوا، برضه بهمنا نعرف قديش الافكتفنس. اوكي، الافكتفنس بتعتمد على الطريقه اللي احنا بندخل فيها الهواء ماشي، او من الطريقه اللي بنوزع فيها الهواء within الoccupied space وعلى البريذنج زون. يعني مثلا هون بحط لك الاير ديستريبيوشن كونفيجريشن، لو كان مثلا ceiling supply of cool air، ceiling supply of warm air، return هياته. الاي زد اللي هي الافكتفنس تبعته 1 مثلا. هلا هون ceiling supply of warm air 15 فهرنهايت 8 or more above اللي هي space temperature and ceiling return، برضه هاي إلها تصنيف. يعني الواحد بده يعرف بالضبط شو الكونفيجريشن او شو الطريقه اللي بتم فيها سحب الهواء وتدخيله لجوات المبنى. بناء على اساسها هاي في عندك تيبل موجوده في الستاندرد تعطينا قديش مقدار الافكتفنس. اوكي، وهي اللي هو تيبل 6.2. هلا لما نعرف مقدار الافكتفنس احنا بنقدر نشوف فعليا هل كل الاوتدور اير رح يتوزع عندي بشكل صحيح او لا. هذا مثلا من ضمن التيبلز الموجوده عندنا باخر اللي هو في الاندسيز الموجودين عندي. هاي مثلا اعطاك description ceiling supply of cool air and ceiling return اللي هي بتكون اللي هي المعلقه الموجوده عندي هون. هاي مثلا from outdoor air supply fan، هيها بتفوت عندي هون. هاي الافكتفنس تبعتها 1 لانه covers most of the area. اوكي، وهي في عندك هون الريتيرن طالع ماشي. هلا في عندنا مثلا الثيرمال اللي هي displacement لما تكون موجوده عندنا، هياتها اعطاك هون الكفاءه تبعتها عاليه شويه هذه. هاي الريتيرن فوق، وتحت في عندنا هون اللي هي الفان اللي بتكون ماشي فوق بتعطيني توزيع اليونيفورم للتمبريتشر ماشي. ففي عندنا التيبل هذا برضه كمان موجود عندي في الاخر وبيعرض لي بقدر كمان اخذ منه قديش مقدار الافكتفنس. هاي في عندنا امور ثانيه كثير حسب الديسكربشن، يعني عشان الوقت ما راح اقراهم كلياتهم، بس بورجيك الرسم بالضبط توضيحيه وبعطيك بالضبط قديش الافكتفنس اللي انت رح تاخذها ونحطها وين؟ نحطها في معادله 6.2. اوكي، اللي هي رح تعطيني الزون اوتدور اير فلو هياتها اللي هي بتساوي لي البريذنج زون على الافكتفنس ماشي. قديش فعليا انا الافكتفنس تبعت الاوتدور اللي ودخلته على البريذنج زون تبعتي، قديش فعليا اللي هي صار في عندي اير فلو within الزون تبعتنا. فهيها موجوده اللي هي في بي زد مقسمه على مين؟ مقسمه على الافكتفنس اللي بنجيبها من التابل. هلا طبعا الزونز عندنا انواع كثيره ومختلفه. لو كان في عندي مثلا single zone system، شو يعني single zone system؟ for ventilation systems wherein one or more air handlers supply a mixture of outdoor air and recirculated air to only one ventilation، يعني عندي بس وحده. اوكي، فبالتالي شو راح يكون موجود عندي؟ فبالتالي راح يكون عندي اللي هي الاوتدور اير انتيك فلو الفي او تي راح تساوي لي الفي او زد اللي هي اخذناها من معادله 6.2. كمان لو كان انا في عندي 100% outdoor air system ماشي الحال، لان كنا بنسحب الاوتدور اير سيستم من الخارج، بقول لك for ventilation system wherein one or more air handler supply only outdoor air to one or more ventilation zone ماشي الحال، راح يساوي لي وقتها الاوتدور اوكي حاصل مجموع الاو زد لكل الزونز مشان ناخذهم كلهم في عين الاعتبار، بتطلع على كل وحده بتجمعهم مع بعض، فوقتها بيكون فعليا قديش مقدار الاوت دور. هلا مالتيبل زون ريسيركيوليتنج، مش كله 100% اوت دور، لا في عندي ريسيركيوليتنج المالتيبل. ماشي. هلا بقول لك for ventilation systems wherein one or more air handlers supply a mixture of outdoor air and recirculated، دخلنا recirculation في الموضوع to more than one ventilation zone، برضه في عندي أكثر من ventilation zone. The outdoor air intake flow shall be determined حسب السكشن الموجود عندنا اللي هو 6251، هينا رح نشوفها لحد 6254. ماشي. اللي هو في عندي أول شيء بدك تطلع شيء اسمه البرايمري outdoor air fraction، أوكي، اللي هو الزد بي زد، برضه هذا يغطى في معادلة 6-5، وهيها حساباتهم تاخذها لكل زون في عندي اللي هي قديش انا اللي هي الاوت فلو زون على البريثنج زون. طبعا هاي حساباتها بتاخذها من المعادلات اللي قبل، بيطلع معنا قديش مقدار اللي هي الزد بي، قديش مقدار الفراكشن الموجوده هون. طبعا في بعض السيستمز اللي الواحد بده يعملها شويه معامله خاصه اللي هي الفي اي في سيستم، فبقول لك for VAV system design purpose اوكي البي زد is lowest zone primary air flow was expected at the design condition analysis. لأنه الفي اي في اللي هي variable air volume systems احنا بنصمم في عندنا design conditions وفي عندنا off design conditions، فاحنا لما بدك تاخذ الفي بي زد تاخذها as the lowest zone primary air flow حسب الديزاين condition، مش على الاوف ديزاين، يعني مش على المينيمم لود، مشان نكون بالسيف سايد. طبعا كلياته موجود في الابندكس A. ماشي. هلا برضه كمان للمالتيبل زون ريسيركيوليتنج سيستم في عندي السيستم فنتيليشن افشنسي. طبعا السيستم فنتيليشن افشنسي راح تعتمد عندي على الزد بي فاكتور، اوكي، وهياته موجوده عندي. احنا بنحسب الزد بي من المعادله 6-5، بنيجي بنطلع على تيبل 6-3 وبنشوف احنا موجودين within any category. اذا كنا اكبر من ال 0.55 فبالتالي راح نروح على appendix A مشان نقدر نحسب قديش مقدار الافكتفنس. فيعني هون صار في عندنا شوي الحسابات صارت اعقد شوي لما يكون في عندي multiple zone recirculating systems. هلا في شيء اسمه كمان ال uncorrected outdoor air intake، اوكي، ال uncorrected outdoor air intake. احنا حكينا موضوع الاوكيبانسي جدا مهم، فلو اجينا طلعنا هذا كلياته كفرد في المعادله 6-6. المعادله 6-6 برضه كمان هاي اخذناها من الستاندرد. الفي شو بدها تساوي لدي في summation all الزونز، الار بي اللي هي تبعت البيرسونز في النمبر اوف بيرسونز، اوكي. هلا هاي لحد هون عادي. الدي هلا رح نيجي على تعريف شو هو الدي، زائد all zones اللي هي الار اي في الاريا، اوكي، اللي هي نفس البريذنج زون، بس اختلف عندي دخل عندي موضوع اللي هو الاوكيبانت دايفرسيتي الدي. فالدي موجود عندي هياته في معادله 6-7. الدي شو بتعامل اللي هو قديش مقدار اللي هي البي اس، اوكي، على السميشن اوف اول زونز اللي هو النمبر اوف بيبل الموجودين على سميشن اللي هي البي زد للاول زونز، فبطلع معي فعليا قديش مقدار الاوكيوبنت دايفرسيتي. ماشي، يعني بنشوف النمبر اوف اوكيوبنتس على الاول زونز البي زد لهم، اوكي، اللي بنجيبها من تيبل 6-1، فبطلع معنا قديش مقدار الاوكيوبنت دايفرسيتي وبندخلها في المعادله 6-6، فبناخذ اللي هو المعامل اللي هو uncorrected air intake، اوكي. هاي برضو كمان the design outdoor air intake flow out shall be determined اللي هي كمان بتدخل عندي موضوع الافكتفنس. ماشي، نحن اخذنا قديش الاير فلو، عشان ادخل على الزون نفسه واعرف قديش مقدارها لازم نشوف موضوع الافكتفنس، فبنقسمها مره ثانيه على موضوع الافكتفنس لانه راح يتغير معنا الرقم شوي. برضه الافكتفنس بنجيبها من التيبلز الموجوده عندي في الستاندرد واللي حكينا لكم عنها بشكل سريع قبل شوي. ماشي. هلا في عندنا برضه ديزاين فور varying operating conditions. في عندي اللي هو الفاريبل لودز mainly السيستمز اللي بتغطيها اللي هي الفي اي في، اوكي. احنا بنشتغل على المينيموم للديزاين كونديشنز عشان نضلنا دائما وابدا في السيف سايد ونحصل اللي هي no less than the minimum ventilation rate requirements، اوكي. فمشان نضلنا دائما موجودين وين؟ بالسيف سايد. هلا في شيء اسمه الشورت تيرم كونديشنز. الشورت تيرم conditions هقول لك if it is known that peak occupancy will be of short duration and or ventilation will be varied or interrupted for a short period of time. يعني مثلا ناس بتواجدوا في مدة محددة. اوكي، عامل الزمن عندي عامل مهم. ماشي الحال. الفنتيليشن لانه ما راح يكون على طول ال 24 ساعة the same. ممكن احنا بساعات معينة نضطر نسحب اكثر based on number of people من ساعات ثانيه ما فيهاش occupancy. انت حتخلي جزء دائما شغال for ventilation وممكن اجزاء معينه ينعمل لها شت داون مثلا. اوكي، يعني اللي من خلال لما بدك تيجي تعمل auditing للمبنى ما راح يضلوا the same rate all the time. فلما يكون في عندي variation او راح يكون في عندي اللي هي short term اوكي بالتواجد في او ساعات معينه باوقات معينه، فراح تعمل correction للمعادلات تبعتنا اللي هي هياتها T بدها تساوي لنا 3V over VPZ. اوكي، هاي اللي هي في الانجلش في الاس اي اللي هي ال 50 في على الفي بي زد تي اللي هي الافريج تايم بيريود في المينت. اوكي، والفي بي زد اللي هي قديش مقدار الاوت دور اير فلو للبريذنج زون، والفي اللي هي ذا فوليوم اوف فنتيليشن زون. ماشي، اوف فنتيليشن زون للزون نفسها اللي احنا شغالين عليها. اوكي، واللي هي بدها تساوي لنا ايش مالها؟ ذا بريذنج زون اوت دور اير فلو كالكوليتد من المعادله 6-1. ماشي الحال؟ واضح؟ فبالتالي بتم ايش مالها؟ التعديل عليها وبنعرف قديش فعليا الافريج تايم بيريود في المينتس اللي بدنا نشغل عليها. طبعا هذا الحكي كلياته مرتبط في عمليات الكنترول. ففي عندنا الديماند كنترول فنتيليشن اللي هي DCV Demand Control Ventilation shall be permitted as optional mean of dynamic reset. الدايناميك ريست اللي هي mainly for خلينا نسميها الانرجي auditing تقنين الطاقة في المباني اللي هي expected occupancy sensors والكاونترز. كل هذه الأمور كلياتها بتكون موجودة شغالة تحسب فعليا امتى معدل دخول الناس، معدل خروجهم، معدل تراكم ثاني أكسيد الكربون. هاي الأمور كلياتها يعني ممكن أنت تشتغل عليها بشكل دايناميك بحيث أنها تتم عملية التحكم بفتح واغلاق الهواء بالاير فلو انتيكس، مثلا جهه معينه تسكر جهه معينه، كلياته بيتم هذا الحكي من خلال موضوع الكنترول. اوكي، وفي عندنا هون كمان شغله اللي هي البريذنج زون اوت دور اير فلو shall be reset in response to current occupancy and shall be no less than the building component. اوكي، دائما ناخذ في عين الاعتبار اللي هي الار اي في الاريا لما بدنا نيجي نعمل عمليه الكنترول اللي هي اندر ديماند. بالنسبه للزون دائما ناخذ الفاكتور هذا اللي هي الار اي قديش احنا في عندي ventilation rate per unit area مضروبه في مين؟ في الاريا زي ما حكينا قبل شويه في تابل 6-1. ماشي؟ طبعا اي شيء في الدنيا بده يكون معمول له دوكيومنتيشن. اوكي، والفنتيليشن efficiency برضه احنا بنقدر نحسبها في كل الظروف سواء كانت دايناميك فيها عمليه تحكم او ما فيهاش اي عمليه تحكم، كلياتها ممكن حساباتها. يعني انا ما راح امشي عليها بسرعه مشان عمليه الوقت. اوكي، وخليني اشوف هون اذا في عندنا اكزامبل. انا عندي حطيت اكزامبل انا. اوكي، بس خليني اشوف لكم اياه الاكزامبل اللي حطيته. اتاكد في واحده انا حطيت فيها اكزامبل. رامي انا بعثت لك اللي حطيت فيها الاكزامبل صح؟
اعتقد موجوده دكتور، هلا بحاول اطلع لك اياها. طيب في عندنا
والله
كم
لاني مش عارفه وين راحت هون، بس لاني انا حطيت اكزامبل مش عارفه وين راحت هون صراحه.
ممكن دكتوره تمشي مثلا على اي من التيبلز، تمشي على اي مثلا زون كيف نطلعها وتبلشي فيها من غير حتى كالكوليشن. يعني لو عملتي مثلا كلاس سريعا ممكن نمشي عليها بس بحيث الناس تعرف كيف تطول المعلومات من التيبل.
خلص اوكي، انا عامل حاطه فاتحه الستاندرد عندي هون. هي نيجي عليه. اوكي، نفتحه. ماشي، هذا الستاندرد. ماشي هياته. اوكي، خلينا نيجي على البروسيجرز 6. اوكي، نيجي على تيبل 6-1. هياته هيدا تيبل 6.1. انا الاكزامبل اللي كنت حاطيتها مش عارفه وين راح. اوكي، اللي هو اخذت انا في عندك لكتشر هول، ماشي، كون احنا بندرس في جامعه فيكس سيتس. اوكي، واخذت انه مساحتها 45 متر مربع، هاي احد الكلاس رومز الموجوده عندنا، ماشي، 45. اوكي، والسعه اللي بتوسعها كم من طالب، بنحط حاطين فيها موزعين الكراسي بحيث انها تاخذ 50 طالب، بعرف شو هيك حاطينها بالشكل هذا. فبالتالي هلا هون هاي بدنا نحسب قديش البريذنج زون، اوكي، اوت دور اير فلو ريكوايرمنت. فعندنا الار بي هيها بدي اخذ على الاس اي 3.8 اوكي، هن موجوده عندي هون، ضرب النمبر اوف بيرسونز اللي هم 45، ماشي الحال. الار اي هياتها، الار اي اذا بدي اخذها في الليتر هيها بدها تكون عندي 0.3، ماشي، ضرب المساحه اللي هي ال 45، فحاصل مجموعهم مع بعض راح يعطيني للبريذنج زون. اوكي، طبعا هي الصاله فيها اللي هو الاوفر هيد
يطلع تقريبا دكتوره 190 لتر بير سكند.
ايوه، ثانك يو رامي. ماشي، الافكتفنس لها 1 هياتها حسب هون اللي هي السيلينج سبلاي اوف كول اير، هي الافكتفنس لها 1، فهي هالمعادله حسب هذا الكود اللي انا اخذت منه المعلومات كلياتها. فحسب المعادله 6.2 اللي هي الزون اوت دور اير فلو راح يطلع معنا اللي هو البريذنج زون حسب المعادله 6.1، ماشي، الموجوده ايرلير واللي حطيناها في البرزنتيشن. اوكي، على 1 راح تطلع تقريبا تساوي نفسها،
هي 91 تقريبا او 190 لتر بير سكند.
190 لتر بير سكند. اوكي،
طبعا للاسف معظم الكلاس رومز مش مزوده بميكانيكال فنتيليشن.
لا مش مزود، هذا ان كيس كانت مزوده، يعني احنا اساس انه حاطين هذا الشيء لقدام. ماشي، وهي سنجل زون، فبالتالي راح يكون عندي ايش ماله اللي هو الاوت دور راح يساوي لي نفس الاو زد. اوكي، ما تبقى من كالكوليشنز يعني ممكن الواحد يساويها بسهوله من خلال الرجوع للستاندرد. وانا بهيك بكون خلصت، يعطيكم العافيه.
يعطيك العافيه دكتوره، شكرا لك. في عندنا كم سؤال موجودين. اول شيء في عندنا مهندس طبعا احمد زهران اعطانا بس تحديث على انه الستاندرد كمان في له تحديث سنه 2019 الستاندرد.
والله
بالضبط.
طب يلا كويس.
هلا سأل المهندس احمد سؤال كمان بيحكي لك بالنسبه للانرجي ريكفري لازم ما يكون عندنا ميكسينج، بياكد بس على نقطه انه ما يكون عندنا ميكسينج بين الهواء بطريقه انه يصير في عندي كروس كونتامينيشن. بس اذا بتاكد على هاي النقطه وبنناقشها سريعا.
ما يكون عندي ميكسينج، لا اكيد. انا هلا بالنسبه لموضوع الانرجي ريكفري، اذا احنا كنا شغالين على انت بتسحب مثلا هواء من برا درجه حرارته على سبيل المثال 40، اوكي، وبدك تدخل بدك تبرده وتوصله، خلينا نحكي لاوبريتنج تمبريتشر تساوي 25، الدلتا تي ما بين مثلا ال 40 وال 25 هي راح تكون ايش مالها اعلى ما بين الدلتا تي مثلا على سبيل المثال وال 30. لو انت سحبت من الريسيركيوليتد اللي هو اوريدي انت تعبت عليه واوريدي عملت له اير كونديشننج ودخلته، فدائما الميكسينج يعني انا حسب ما بشوف وحسب ما بعرف دائما الميكسينج اوف تو ادياباتيك ستريمز هو بقلل الكونسمشن على الاير كونديشننج يونت، لانه اذا بضلني اسحب بس اوت دور اير من دون ما اعمل ميكسينج او اخفض اوكي في مقدار الدلتا تي اللي بدي احطها في الاير كونديشننج يونت، اكيد ديفينتلي راح يكون في عندي كونسمشن عالي. يعني انت ما يكون عندك الدلتا، كل ما زادت الدلتا تي كل ما زاد الكونسمشن على اليونت.
تمام. والمهندس بس بياكد على موضوع انه ما يحصل ميكسينج وكروس كونتامينيشن عشان ما يصير تلوث.
اكيد ديفينتلي لازم يكون في فلاتر، لازم يكون في فلاتر للريسيركيوليتد اير حسب كلاس الهواء. مش كل الارياز احنا اصلا نقدر نعمل منها ريتيرن، يعني هاي وضحناها في موضوع الكلاسيفيكيشن للهواء.
صحيح 100% صحيح دكتوره. طيب في عندنا جعفر عظيم سأل سؤال بحكي انه هاو تو كيب مونيتورينج ذا اير كواليتي، هل بكفي CO2 سنسورز بس؟ واذا في سيستمز ريكومندد نحكي له عنه.
لا طبعا اكيد مش بس السي او 2. هلا هو السي او 2 هو از ون اوف ذا ميجر، لانه مينلي احنا البيبل وي ار بريذنج اوت ثاني اكسيد الكربون، في عندنا الامونيا، في عندنا الفورمالديهايدز، في سنسورز لهي الامور كلياتها انت بتقدر تاخذها وتفحصها، وفي الاير بامبس كمان انت بتقدر تسحب عينه من الهواء، ماشي الحال. يعني طبعا الواحد بيقول لك كيف اسحب عينه، لا موجوده، تبقى اير بامب صغيره اوكي وبنحط فيها سنسورز خاصه في اللابراتوريز. طبعا اجهزه القياس كثيره ومتعدده، ويعني مش بسهوله انه المبنى الاوكيباي اوكيبايد اجي انا احكي انه بدي اضلني انا مونيتورينج كل الانواع الموجوده فيه، فانت رح تاخذ كميه معينه وتركز عليها. مثلا اذا هو مش مصنع، مش لابراتوري، مش مكان، انا بعرف انه الموجودين مثلا قاعه طلاب، اذا اكثر شيء رح يكون متواجد عندي اللي هو الامونيا، الاسيتون، السي او 2. بتوقع انه اكثر نسبه رح تكون موجوده عندي اللي هي ايش مالها، مثلا السي او 2 سنسورز. اوكي مثلا اماكن عارفين انه فيها اوريدي رطوبه، ممكن مثلا بين فتره والثانيه تشيك على الجدران بحيث موضوع المولد جروث والفنجس. اذا كان عندك سيستمز ميكانيكيه بدك تاكد كمان على انها تكون منظفه باستمرار بحيث انها ما تطلع لك مع الاير ستريم. يعني بدا في تريتمنتس كثير، في خلينا نسميها بروتكشن بروسيجرز موجوده، بس في سنسورز كثيره، في سنسورز لكل معظم الانواع البوليوتنس في لها سنسورات موجوده.
طيب في عندنا سؤال من مهندس ابراهيم جابر بيحكي انه شو يعني what is the effectiveness of available filters؟ شو الافكتفنس تبعت الافيلبل فلترز على الكوفيد 19؟ في شيء معين بفلتر الكوفيد 19؟ في حدا سمعت عن شيء اخذ سيرتيفيكيت شغلات معينه؟
والله بصراحه انا بالنسبه لي ما سمعت لحديت الان، ما سمعت، وعملت سيرش في النت اذا هو بيعرف يزودنا في المعلومه، بس انا بالنسبه لي ما سمعت عن فلتر، سمعت عن الدي اينايزرز. في بعض انواع الدي اينايزرز شغالين عليها بتركيا على فريكونسيز معينه بتفكك الفيروس، بس فلاتر صراحه ما مرقت علي، فاذا حد عنده معلومه يزودنا فيها.
في معنا محاضره الساعه 6 تقريبا راح تكون لنيكولا من ايطاليا، هو راح يحكي عن هذا الموضوع راح تلاقي جوابك مهندس ابراهيم في ضمن هاي المحاضره ان شاء الله. تمام؟
ان شاء الله.
في عندنا سؤال how can we apply these equations to HAB؟ هل هاي الايكويشنز موجوده بالهاب؟
موجوده في الهاب، بس الهاب يعني للاسف في بعض الامور الديتيلز التايني ديتيلز مش موجوده في الهاب. اوكي، الهاب مينلي هو بيتعامل مع البيلدينج از بيلدينج، بحسب لك قديش اللود، بعدين انت بتختار نوع الميكانيكال سيستم اللي بدك تحطه، طبعا بناء عليه في الافكتفنس برضه موجوده بيلت ان، بس في بعض الديتيلز اللي هي السبيسيفيك ديتيلز لا مش موجوده، انت بدك تروح اللي هي في لها كالكوليتر، الاشري 62 في لها كالكوليتر، يفضل انك تحسبها بناء عليها، يعني تاخذ موضوع الفنتيليشن تفصل لي اياه شويه عن الهاب. يعني الهاب هو كسوفت وير انت عملت معه كويس، بس في بعض التايني ديتيلز مش موجوده فيه، ممكن يعطيك اوفر استيميشن او اندر استيميشن احيانا.
طيب في معنا دكتوره 3 اسئله وفي مداخله بسيطه، ناخذ ال3 اسئله سريعا بعدين بندخل مهندس سيد صالح. في عندنا سؤال بيحكي which is system يعني مين احسن CAV or VAVs require more fresh air quantity؟ بس بالVAV ولا بالCAV؟
الVAV
لانه طبعا الCAV كميه محدوده وثابته.
انا الكميه محدوده، لا الVAV احسن، الVAV دائما افضل.
عندنا سؤال هل بحاجه لموازنه الهواء بين الهواء الداخلي وخارج المبنى؟
اكيد طبعا الاير بالانس ضروري في الماس بالانس في طبعا ضروري، وهذا بدخل في حسابات. هون بصير في عندي اوفرلاب ما بين الاندور اير كواليتي بروسيجر وما بين الفنتيليشن ريت بروسيجر. انا باخذ قديش كميه الهواء اللي هي باخذها من الفنتيليشن ريت بروسيجر، اوكي، وبدخلها على الاندور اير كواليتي بروسيجر مشان موضوع الماس بالانس within الاوكيبايد سبيس، مشان اقدر اعرف بالضبط قديش لازم يكون في عندي دايلوشن للكونتامينتس. فهون بصير في عندي اوفرلاب بين التو بروسيجرز الموجوده، فضروري يكون في عندي ماس بالانسنج، والا يعني رح يصير في عندنا خلل.
طيب في عندنا سؤال من مهندس اشرف when and which field we must use air change method؟
air change method هاي للانفلتريشن. الاير تشينج ميثود الانفلتريشن، حسابات الانفلتريشن في عندك انت الكراك ميثود واللي هي اوريدي بيلت ان السوفت ويرز الموجوده في الهاب وبتاخذ فيها ديتيلز كثير، والاير تشينج ميثودز يعني بتيجي شويه دقتها اقل من الكراك ميثود، بس يعني يو كان يوز بوث اني وقت ما بدك، ما بتفرق متى بدك تستخدمها، بس بدك تستخدمها بحسابات الانفلتريشن اللي بياثر على اللود. ماشي، يعني انا مش رح اجي احط فلتر صغير جنب الشباك، يعني قديش يكون حجمه، هذا عندي كراك الشباك ولا عندي كراك من الشمني، انا مالي بأثر على اللود، فحسب قديش بتغير الهواء وحسب معلومات المبنى بصفي عندك الاير تشينج ميثود كويسه يعني.
طيب هيك دكتوره خلصنا الاسئله. في معنا اخر مداخله المهندس سيد. مهندس سيد تفضل اذا عندك مداخله تحكيها. تفضل مهندس سيد معنا.
السلام عليكم.
عليكم السلام. تفضل مهندس.
يعطيك العافيه دكتوره شذا، محاضره ممتعه، وشكرا مهندس رامي على المؤتمر، وانتم دعيتونا للمؤتمر، ولكن والله كانت عندنا ظروف ما كان عندنا شغل يعني بالوزاره. انا المهندس صالح من وزاره البيئه، بالنسبه لنا الاوت دور اير كواليتي اللي حكيت عنه، احنا في عندنا بالاردن الشبكه الوطنيه لمراقبه نوعيه الهواء، وانا كنت في المؤتمر الماضي اعطيت محاضره عن الموضوع.
صحيح.
مظبوط.
بشرفنا حتى لو هذا في مجال، اذا في مجال بنعطيه.
والله يا ريت نتعاون معاكم، يعني بالعكس شيء جميل جدا.
احنا عندنا الشبكه الوطنيه لمراقبه نوعيه الهواء المحيط، عندنا 27 محطه رصد مباشر لمراقبه نوعيه الهواء في المدن الاردنيه في 7 محافظات. وفي بالزرقاء يعني عندنا عده محطات في الهاشميه، في 3 محطات في منطقه الهاشميه، لكن مثلا محطه الحسين الحراريه تم توقيفها. تم توقيفها وتم انشاء محطه جديده، هي محطه الزرقاء لتوليد الطاقه الكهربائيه.
مظبوط.
والحمد لله يعني كمان تعاوننا مع مصفات البترول الاردنيه، وتم تخفيض الملوثات بشكل كبير في منطقه الهاشميه، وصارت تحت الحدود المسموح فيها.
طب حلو والله، ممتاز. يعني وصلتوا للنسب المطلوبه.
نعم.
طب حلو.
يعني حتى نوعيه الهواء بنقدر نحكي في الاردن نوعيتها جيده لمعتدله.
هي معتدله، هي تصنف معتدله، يعني ما عدا الغبره اللي بتيجي من برا، عادها شو ننسى.
جيده ومعتدله، حتى يعني حوالي 70% بتكون جيده، 20% معتدله تقريبا، 10% بتكون مرات حسب العواصف الترابيه. احنا عندنا منشوره بالطبع على ويب سايت الوزاره التقارير الدوريه، في تقارير يوميه وفي تقارير سنويه منشوره على موقع الوزاره. وفي عندنا الشبكه الوطنيه اللي في لها ويب سايت jordan.env.com، ممكن تدخل عليه مباشره وبتشوفوا مربوط عليها 13 محطه رصد مباشر. حتى ربطنا مع
والله يعني معلومات كويسه الواحد يستفيد منها.
دكتوره عندنا وزاره البيئه هلا اشتغلت دور زي دور الناشونال امبيانت اير كواليتي.
انا بعرف انه دورهم صار كثير واضح، انا بعرف.
الله يعطيهم العافيه، وبالعكس
مستعد انا
اتعاون معهم دائما.
ان شاء الله اكيد مهندس راح يكون بيناتنا تعاون.
واذا مهندس رامي انا يعني مستعد لاي وقت، لكن والله اجت المعامله وكان عندنا شغل كثير وبتعرف الظروف.
مهندس ان شاء الله المؤتمر القادم في ترتيب معكم على شيء ان شاء الله افضل شوي.
اي وقت بترتبوا الادوار
الشغل تكون
حابين نشارك فيه معكم. الله يجزيكم
ان شاء الله.
الله يعطيكم العافيه. يعطيكم العافيه جميعا. مساكم خير. Good afternoon everybody here in Amman time, and good morning to everyone else watching us from USA. Dr. Marwa, good morning for you. Thank you for having you on board in our conference. We are very glad to have you on board. Dr. Marwa will deliver a presentation today about HVAC strategies in the age of COVID-19. For Dr. Marwa, we would like to say something about her. She's a PhD in environmental engineering from the University of Texas, Austin. She has a master's degree as well in engineering management from the American University of Beirut. Dr. Marwa is an ASHRAE distinguished lecturer actually. She delivers lots of lectures about indoor air quality, standard 62.1, particulate filters, etc. She is the vice chair of the committee of 2.3, I guess 2.4 as well. She's very active. She's been doing the business of indoor air quality for ASHRAE since I know her more than 10 years or maybe 12 years. And we're very proud to have her on board. As I told you, she's one of the real distinguished lecturers, especially in the field of indoor air quality, because it's her specialty since quite a long time. She served in so many ASHRAE committees, and she is in the committee that puts the standard 62.1 and also the standard 145.2 for the laboratory testing methods. Dr. Marwa, thank you very much for coming. And the mic is yours if you can introduce more about yourself and start your presentation. Thank you very much.
Thank you, Rami, and thank you everyone for attending today, and thank you for having me. I'm also on the ASHRAE Epidemic Task Force, and I'm involved to put the COVID-19 guidelines in commercial buildings, communities of faith like churches, mosques, and others, and also how to get the building ready to reopen safely. And finally, we now have a group to issue some guidance about portable air cleaning and to evaluate the different tools to estimate the risk. Anyway, so my presentation today is about HVAC strategies in the age of COVID. So from the beginning of this pandemic, we know that the HVAC system can play a very important role in the solution. and can help to mitigate the risk of transmission of COVID-19. But even myself, and I'm on the ASHRAE Epidemic Task Force, it was very hard at the beginning to digest all the information. So we were bombarded by a lot of strategies and a lot of equipment. And you've probably heard this before, everyone is trying to sell something. But these strategies are about mainly, ventilation with outdoor air, about filtration and some other like basically related to operation and maintenance. But here the challenge is that some of these strategies are contradictory. For example, at the beginning of this pandemic, we're told do 100% outside air. If all the air in your building is 100%, then it doesn't make any sense to upgrade your filters, specifically for COVID, because your filters are going to clean indoor air. And if you only have 100% outside air, then there's no indoor air that's being recirculated. And also there's some challenges that come with outdoor air. For example, pollution, relative humidity, and some spaces do not have capability by design to do outside air. And I have to say, since March till now, we've come a long way in terms of these strategies. Before I tell you what ASHRAE came up with as core principles or core recommendations, I want to show you this graph. And I showed this graph 10 years ago, 5 years ago, and also today. In my work, I deal with a lot of clients to have a pandemic plan, how to reopen safely, whether it's schools, universities, offices, whether it's gyms, theater, fighting arenas. And when you come to the real life or the practical application for it, there's always a question. How can we know that we did enough? How can we know it's safe to reopen? How can we balance the risk and the cost, can be first cost, operating cost, and also if you have sustainability goals, how can we balance also sustainability goals and the impact on the environment? So this graph, I basically tailored it today to be descriptive of this pandemic. If you look at number one, I have pandemic, usually I have poor indoor air quality. You've always heard that we spend most of our times indoors, 90% of our time indoor, and we typically deal with poor indoor air quality. Today, we're dealing with something similar, which is a pandemic, so number one. And then when we are dealing with this problem, then we have strategies, so you go to number two. Most of these strategies will incur energy consumption. And for example, if you have more outside air, then you're paying more, or you're producing more energy to cool and dehumidify the air. If you're putting an air cleaner, you're putting, for example, fan energy, etc. So we put energy, and what happens when you put energy? You contribute to more emissions, outdoor air pollutants, basically. And if you're bringing it to dilute indoor air pollution, then you are, contributing more to the problem. So I call this the vicious cycle. And I believe that there is a better way to do it. There is a way to combat this pandemic while at the same time being energy efficient, and while at the same time to decrease emissions, outdoor air emissions, and meet our sustainability goals. And if you do a quick search on Google, if you put COVID-19 and also you put climate change, you have many of these headlines. And many of these headlines basically will say that, there is a link between COVID-19 and climate change. At least we have 3 studies, and I know there's a speaker after me from Italy, but basically 3 studies, one in Italy was done in the northern region, one from California, and one from Harvard Public School of Health. And the 3 of them, they say that if you have high outdoor air pollution, it was linked to COVID-19 mortality. So there is a link between COVID-19 and mortality, and maybe COVID-19 and transmission between outdoor air pollution. Now, when I write pandemic plans to our clients, this is the approach I follow. The first one is airborne transmission. So we are dealing with airborne transmission. And here what I mean by airborne, I know there's a lot of debate about it, but can be long range transmission, basically through HVAC system, or can be short range transmission, basically, from person to person, but beyond the 6 feet or the 2 meter, distinction. The second one, it's a multi-layer defense strategy. It's very important. And if you follow me on social media, this is my whole spiel. There is no magic bullet. There's no one solution that can solve our problem or, the magic cure. It's a multi-layer defense strategy. And you're always trying to make your space safer, not safe. And my other spiel is that we need to focus on the basics. So in all my plans, there is no fancy technologies, to say it nicely. It's all focusing on the basics of basically ventilation, the basic of particulate filtration, and maintaining your system. The third one, you have to have an understanding that if you're doing a plan, it has to be specific per your space type and also activity type and duration. You know, doing a classroom is very different than doing your home or basically a theater or something else. So it has to be by space type, activity, and duration. And the last one, so you can stop here or you can go one more step and basically talk about the risk. So actually estimate the risk while considering different strategies. What is the energy impact? And also what is the carbon impact assessment? So you can have many strategies and then choose the strategies that will work, you know, specifically for your project. And here it has all to do with basically performance-based approaches. Now, ASHRAE published 400 pages of guideline for COVID-19, distributed by different building types. We have many different organizations that also published COVID-19 recommendation. I want to present for you here a very clear and a summary of all these recommendations. We're calling them the core recommendation. So if you start by these and you turn them into a checklist, you will have a very good start. The first one is from ASHRAE, which is the minimum outside air. So Dr. Amoura before me, she talked about the 3 procedures: the prescriptive approach, ventilation rate procedure, the indoor air quality procedure, which is a performance-based approach, and lastly, the natural ventilation procedure. So you have to have a minimum outside air. And I also heard that schools, and I'm familiar with that, in our region, basically, they don't have ventilation. And I can show you an example how to deal with that. The second one is to have MERV 13. So this is the filtration efficiency. I will talk later in details about this. I also saw a question about filtration. But then they say, or equivalent. The equivalent here is key. For example, a lot of our clients, they have double stage filtration, like a MERV 7 and MERV 11, or MERV 7 and MERV 10. If you have double stage filtration, you don't need to upgrade each filter to MERV 13. You might get away with it if you can prove that the combination of filter is equivalent to MERV 13. And last, we have basically air cleaning. It can be portable air cleaning. It can be, you know, ceiling mounted. It can be wall mounted. There is a lot of these air cleaning. But here I'm talking specifically about the basic air cleaning, a fan and a filter, the basic filter. The third one is to, you know, it goes without saying, but maintain design temperature, relative humidity. Number 4, flush out. I have a slide about flush out, and flush out means you clean your space before people come in, either in the morning or at night, or for example, if you have a community of faith like a mosque, you basically, if you have 2 services, you wait and you clean between the 2 services, you clean the air. Same thing if you have a classroom or theater, etc. Number 5 is to maintain your system. Goes without saying. You can design the best building, but if you don't maintain it, you're not doing a good job. Number 6 is target air exchange rate. And I'm not sure where, I don't remember the name of the engineer that asked about this. So typically in ASHRAE standard 62.1 for commercial, educational, you know, retail, gym buildings, we do it CFM per square foot plus CFM per person, as Dr. Shaza mentioned. For this pandemic, Harvard and UC Boulder introduced one more metric, which is air exchange rate. Typically, we only have air exchange rate in hospitals, standard 170. What is air exchange rate? Air exchange rate, as the name indicates, is how many times you're changing the air in your building per hour. So if you have an air exchange rate of 6, you're changing the air in your building 6 times. It's a very easy equation, especially when it comes to outside air. You take the outside air volume and outside airflow volume, so meter cube per hour, and you divide by the volume of your space, meter cube, and you obtain 1 per hour. Now, what happened is that for COVID-19, Harvard Public School of Health and UC Boulder, Colorado, they came up with this, I put here on speedometer, with this guideline of what the air exchange rate should be. And you can apply this into your office building, your home, or a classroom. And they say it should be minimum at least 5 air exchange rate. So 5 air exchange rate, and basically the description is excellent. So anything above 5 is excellent. So when you're trying to do a pandemic plan to reopen safely, and you can basically go through these recommendations. Number 6, you can assign a specific air exchange rate, which would be 5. The key here is that the air exchange rate doesn't have only to do outside air. This is really important. And specifically if you don't have outside air by design, it can be as well filtration, so from indoor air filters, and it can be as well portable air cleaning or in-room air cleaning. And for filters, if you put filters, it's very easy to achieve a very high air exchange rate. I will show you later an example. And we call this metric now effective air exchange rate. So it's a sum between any basically device that can give you air cleaning. On one condition is that you need to know actually the efficiency and the airflow. So you can't just make up a number, you actually need to know it and apply it. So outside air filtration and in-room air cleaning. Now about filtration, and I basically want to take a brief moment before I show you basically the example, because I see this topic, there's a lot of confusion about filtration and whether filtration actually works. And there's a lot of confusion from specifically electronic air cleaners. They try to sell, different electronic air cleaners by saying that the actual basic filtration do not work. So from the beginning of this pandemic, we were told 2 pieces of really bad news. The first one is that the COVID-19 or the SARS-CoV-2, which is the actual virus name, is very small. How small? 0.12 micrometer. I know Engineer Salah said, in where you live, you have many different air quality station to monitor the air quality. I'm sure one of them is PM2.5, another one is PM10. So imagine this. All what we've been caring about is 2.5 micron or 10 micron. And now they tell us that the new virus is 0.1 micron. And just for, to put things into perspective, the average diameter of human hair, one human hair, which you can barely see, is 50 micron, 50 micron. So this virus is really small. The other piece of bad news, and there's still maybe a lot of debate about it, is the virus can be airborne. So it's very small, it can be everywhere. So everyone start to say, okay, we're doomed, start to be like big headlines about this. However, we also know, and this is not very new, this is, decades of research, is that the virus, the coronavirus family does not exist naked. So what does it mean does not exist naked? It means is that it basically has to latch to other particulate matter or other bodily fluid. Why I'm telling you this and why this is very good news, I'm showing you an example of research that basically say, when we cough, when we sneeze, when we talk, if we are at the gym, if we are sleeping, we produce not only one size, we produce a myriad size of particles. So this is a wide range of the size of particles. And this is an example of particle size distribution. It basically say, the good news is 60% of the RNA of the virus is above 1 micron. And this basically explains why is this good news. So this graph shows the one on top, efficiency on the y-axis. On the x-axis, it shows particulate size. So first notice is that it's basically an inverse bell curve. So it's a bell curve. And you see basically the lowest efficiency is somewhere between 0.1 to 0.3 micron. What does this mean? Above 0.3 micron, filters are very efficient. Below 0.1 micron, filters are very efficient. So when you hear that HEPA filters is certified at 0.3 micron, it doesn't mean they cannot remove below 0.3 micron. It means this is a point where they have the lowest efficiency. So again, above 0.3 micron, very efficient. Below 0.1 micron, very efficient. So what we're talking about, the most particle size of interest is between 0.3 micron to 5 micron. And what I told you before is 60% of the virus RNA is above 1 micron. And if you follow with me, a MERV13 that we know we can put in our buildings, that's readily available, that we have the third-party efficiency test, there is established ASHRAE test and also international tests like ISO for a long time, actually works and works very well. And you can follow with me here, MERV13, orange, and you can follow the efficiency. Above 1 micron, the efficiency is above 85%. So this is where the good news lie. So imagine this, most of the air in your building is recirculated air, at least 80% of it. This 80% is going through a very, very efficient filter. If you hear this and you have some outside air and you're operating and maintaining your building, you don't need to do much more. And you don't need to say, oh, I can't open my building safely, or I need to buy these magic technologies that are not basically vetted correctly. Now, if you look at the efficiency table, just to put things into perspective, even if you have a MERV 7 today, you have 44% efficient. MERV 11, 72% efficient. MERV 13 is 87% efficient. And if you don't know what MERV is a minimum efficiency reported value. It's a rating that gives you basically for each filter, it gives you a number from 4 to 16. HEPA is not in this same rating, and give you basically an efficiency for different particulate size. And the nice thing is that this test is readily available. I'll show you later an example. So how to choose particulate filtration? There's also a lot of myth how to choose a particulate filter. Typically, there's a first cost of the filter, the energy consumption, there's a pressure drop, and there's the actual efficiency. The first good news, as I mentioned, I'm gonna re-mention again, is that it's very easy to ask your distributor or your manufacturer for this ASHRAE test that tell you the pressure drop and efficiency. So it's not a black box, it's something that we have access to for a long time. We have in our building and actually works very well. But this, and the first myth is that if you have a high efficiency filter, then you will have a high pressure drop. And I hear this from all my clients. Oh, I cannot put a MERV 13 because it's gonna choke my system. This is not actually necessarily true. I show you here a database that I have. Now I have around 138 different filters. Each red dot is a unique filter. On the y-axis is a pressure drop. On the x-axis is basically different MERV category. So the higher the MERV category, the higher the efficiency. For the sake of the comparison, I made all of them at the same phase velocity and all of them the same basically depth of the filter. So to take away from this slide, the first one is that like you can have a same MERV 13 and you can see here basically the range of the different filters, and it's a range. So the range of pressure drop. So if you basically have a MERV 13, you need to dig deeper in the test data to know what is the pressure drop, because it can vary. So MERV is not equal MERV. This is myth number one. Myth number two is that it's not necessarily, and you look at between MERV 13 and MERV 8, it's not necessarily if you have a MERV 13 to increase the pressure drop on your system. This is extremely important. You can actually have a MERV 13 that have lower pressure drop than your current system. And I did this in my home and I do it to our clients. I ask them, okay, what do you have today? Let's look at the actual make and model of your filter. Let's get the data, which is again readily available. Let's plot it and we put it here. And then we choose a MERV 13 that is equivalent to what they have today in terms of pressure drop. The other thing I want to show you, again, each dot here is a unique filter. MERV 13 is in green, MERV 11 is in red, and MERV 8 is in blue. You have efficiency on the y-axis, and on the x-axis you have pressure drop. So the first thing I want to tell you is that not all the MERV 13 will have the same efficiency. Similar, not all the MERV 11, not all the MERV 8. And here, if you want to like have better performance, again, you take the data from the manufacturer and actually you take a look at it, and you can have a specification specific to a particulate size. And in this way, you make sure that you're having, what you're paying for is you're paying for the highest efficiency and the lowest pressure drop. The other one, which is extremely important, and I don't think we also talk about it a lot, is the filter bypass. And by filter bypass, I mean, when you put your filter in the air handling unit, if you don't fit it very well, you will have air gaps from top, bottom, right, or left, or between the filters. Filter bypass is extremely good to take care of. To give you an example, there is this basically scientific study that take a look at what is the impact of filter bypass on efficiency. And I put here a snapshot. I have the basically the study in a link. Please take a look at it. But basically, if you have a MERV 15, you saw a MERV 15, and you have a 10 millimeter gap, so 1 centimeter gap, very, very small gap, a MERV 15 will act like a MERV 8. So imagine this, like you paid for it, you put it, probably was a headache, to put it in. If you leave a very small gap, it's gonna act like a MERV 8. So this is more to say that is important to take care of the filter bypass. My next topic is coil cleaning. Similar to filter bypass, I don't think we talk enough about coil cleaning, but they are important. They're important because all the air in our building go through coils, heat exchanger coils, can be heating coils, and in our case, it's more about cooling coils. And coils can impact your energy, can impact your indoor air quality, and also can disseminate pollutant back to the airstream. And I put here a study from the largest indoor air quality database ever done in the United States. They basically say, if you clean your coils twice per year versus one time per year, you actually will have a decrease in respiratory symptoms and also like productivity. So it's important to take care of your coils. And I did this piece, like the dirty secret of coils and filters. So this is part of the maintenance. So make sure that your coils are clean, are well placed, and your coils are clean. And the objective when you choose coil cleaning, you need to make sure that you are cleaning deep throughout the entire depth of the coils, and you're not re-aerosolizing any particle that's stuck in the airstream. This is specifically important in COVID-19. And also, I know that there are a surge in UVGI. I put here a link for you that explain what are the considerations when you are speccing UV. And this is an example from an ASHRAE-funded study. I also put the link. On the top picture is a coil in Tampa, Florida. So when they came, they find the coil like this in the top picture. You can see clearly the coil is fouled. This is before application. And what they did, they basically got UV light, a very high intensity. They left it for a long time, 13 months, while changing it, while monitoring everything. The water temperature, inlet outlet, the air temperature, environmental conditions, and the fan power and speed and all of that. And after 13 months, and this is very controlled study, they found the coil like you saw it in the bottom picture. So yes, you can argue that the coil improved, but the study concluded very clearly is that if your coil is fouled, don't put UV and expect that the fouling will go away. If you're considering to put UV, you need to clean your coil mechanically. You need to make sure your coil is clean first. And this is a picture that my team took. It's on the right-hand side. It's UV light installed in a mechanical room, basically in an air handling unit after the cooling coil for 7 months, and still you can see clearly stuff are still growing on the coil. So you might ask yourself, why is that? Why stuff are still growing on the coil? First thing is that, as I mentioned before, the virus does not exist naked. So the virus to be inactivated, the light has to see the virus, has to shine on the virus. So if the virus is encapsulated in a bodily fluid or different particulate matter or spores, simply the light is not going to see the virus. The second one is dose and duration. And I've seen a lot of abuse in how we sell UV. Long story short, if you don't know what you're paying for, if you don't know what is the dollar per risk reduction, you shouldn't spec or install or buy any equipment like that. It's extremely important to have the dollar per risk reduction. So actually for UV, and this is very different than electronic air cleaners, for UV, we have an ASHRAE standard and ASHRAE guideline. We know UV in principle work, but you need to make sure that the intensity, so the dose and duration are correct for your application. Like if you put the UV behind the cooling coil where it's cold, the lamp intensity output can be lost 55%. So it's very important, okay, you're putting it before the filter, before the coil, or after the coil, or basically in room, how much duration of exposure. You need to get this from the manufacturer, have an engineer to take a look at it and spec it correctly. Depreciation, I think it's very well understood, because the light intensity will basically diminish with time. Surface loss, so it's not a plug and play. If you are retrofitting today your air handling unit with UV light, it's not plug and play because you have to shield any organic material. Like for example, if you put it before the coil, after the filters, they're gonna ruin your filters, etc. And then the last one is safety. Make sure, because it's gonna be a maintenance nightmare, safety for the skin and for the eyes. Now about other strategies, electronic air cleaners are basically referred to technologies that use basically any type of ions, plasma, reactive oxygen species, ozone. They have a lot like any radicals basically. They come up with these fancy names. They all mean the same thing. They apply a high energy to the air, and basically they contribute to more indoor air pollution. So there are two problems with them. And I put here the ASHRAE website, what ASHRAE said basically is none of these technologies are proven. Very important is that we don't have an ASHRAE standard today because many of these technologies did not approve or agree to bring their prototypes so ASHRAE can test it and give it to a university basically to do the research. So this is extremely important. And you can get this from the ASHRAE website. They're not proven. And also the Center of Disease Control say they call them emerging technologies. We don't know if they work. We don't know if they're harmful. And they talk specifically about needle point bipolar ionization, but also about plasma, there is a lot, so I cannot mention all of them. But basically, please check this link. And I have an example in the next slide for you. Energy recovery ventilation, it says it depends. You have to do your homework to make sure if it's leaking back contaminants back to the airstream. There is a very a large guidance in the building readiness on ASHRAE website how to do that. Demand control ventilation, no, because here the idea is that you don't want to change your outside air on demand. You want to say, okay, how many people are returning to my building? As the Dr. Shada mentioned before me, you calculate what is the minimum outside air for the number of people that are returning, and you set it constant. You don't need to vary it. The last here is flush out. So flush out refers to basically how much outside air and how much time. Flush out doesn't mean 100% outside air and doesn't mean you have to open your building 2 hours before and 2 hours later. You can do a performance-based flush out. For ease of use, I did this graph and feel free to use it. On the y-axis, there is how much time I need to do flush out. How much time I should basically clean the air between like events or between services or when people go home. And on the x-axis, basically, there is the air exchange rate. And it can be outdoors. I know I have outdoors, but also can be through your filters or can be through air cleaning. And if you follow the orange line, ASHRAE say, reduce your indoor concentration by 95%. So for example, if you have outdoor air exchange rate of 2, you go up and you look at the orange, you only need 1.5 hours of flush out. So if your occupants are coming at 8, you can just start your building at 6.5. And you can have your minimum outside air and your air is going through your filters, and that should be enough. This is a link to a paper that was recirculated recently. I'm not gonna go through the detail, but I wanted to show you is that basically there is a lot of abuse happening in the way that we talk about air cleaning in general. So we have the basic filters that we know they work. They range different efficiency, and also we have HEPA filtration. And as I told you before, they are very efficient and you can get the test and basically take a look at it. Now, the other part is electronic air cleaners, and I'm involved in 6.2.1. I have, a lot of involvement with electronic air cleaners. And this is basically Dr. Offerman. He is a member of 6.2.1. He has 30 years of experience. He's an industrial hygienist. And he wrote this detailed paper about the fake marketing of electronic air cleaner. So please take a look at it if you are looking to buy any type of electronic air cleaners, any type of ion, reactive oxygen species, plasma. Take a look at this paper. I put here the link. And basically what it says, let's assume they are safe. We don't know they are safe because we don't have one test that talk about practical life, like in actually installed in system. We actually have a lot of paper that say they're not safe in terms of ozone, particulate matter, ultrafine, and in terms of formaldehyde. And there are a lot of manufacturers, they publish it's safe, but you come to the published papers, scientific paper that actually tested in real life, they show, okay, the manufacturer says 0 ozone, but when it's actually installed, they have high level of ozone. So if you put the safety aside, there is also a lot of debate about efficiency. So I've seen a lot personally that say, oh, we're 99.9 efficient to remove the coronavirus. And they basically have a Petri dish, they shine the equipment on it in a small chamber and they say 99.9% efficient. But if you install the same equipment in an HVAC system, it can have efficiency, this type, 0.00116. So practically it's ineffective, it doesn't do anything. And I start seeing a lot of the lawsuits about different type of these electronic air cleaners. So I cannot stress enough, do your due diligence and ask the questions, is that how is the efficiency translated when I put it in my HVAC system, in my duct? and give me the safety data and actually installed in the HVAC system via a third-party test. So far, I have not found none, and I would be happy to help you vet equipment. Now, the other topic I have is the trade-off between the different strategies. So here the question is that we have a lot of strategies. How can we choose, and how can we know that we did enough? And again, I'm focusing on the basics, and I want to show you how the basics are sufficient. So again, with the effective air exchange rate, we have filtration, outside air, and in-room air cleaning. On the y-axis, I have effective air exchange rate. On the x-axis, I have different strategies. And the colors show you in red is particulate filtration. In blue is outside air ventilation. And in yellow is basically from an air cleaner that have a fan and a filter specifically. So if you don't have any outside air and you have MERV 13, you can see here basically this column in red, you will have air exchange rate of 6. By the classification of Harvard and UC Boulder, that's ideal. So imagine this, you don't need to do anything else. Even if you don't have any outside air, if you have very good filter and you know the performance of it, you have an air exchange rate of 6. You can always do more. Like if you have, for example, the minimum outside air, the last one, per 62.1, a MERV 13 and an air cleaner, then you can have a very high air exchange rate. So this is a way for you to take, like specify a target and say, okay, what basic technologies I have, what is the air exchange rate? And if you want to go one step more, there are actually a lot of tools that you can go and find today that do risk assessment. Most of these tools are for free. And some of them, like the Jimenez tool, is also in Excel. You can download it and you can basically make it work for your type of project. They have pre-built stuff in it, like for a classroom, university, stadium. And basically most of them, they talk about probability of infection. And you can actually use the probability in your city, like how many people are infected in your city. So you can take a look at it this way, or you can calculate air exchange rate. Now, when I looked at this personally, and I looked at all of that, there was something missing. So great, we know air exchange rate, and we know all the risk, probability of infection. We know, for example, how much time we can spend in the gym, what is the safe exposure time, what is a space safe dose. That's great, but there's something missing. The something missing is what is the energy cost. So I teamed up with my colleagues and we have an energy estimator. We call it the COVID-19 energy estimator. It's also available for free. The official release will be on Tuesday, but feel free to communicate with me. I will put my email on the bottom of this slide. Feel free to communicate with me and I will be happy to send you a copy, or to Rami, and Rami can distribute. But basically, what's nice thing about it, you can use the other tools to calculate the air exchange rate or to calculate the risk. You can, it's optional. Or you can use this energy estimator. So this is standalone energy estimator to tell you what is the first cost operating cost for ventilation with outside air. For different filters, it has pre-built efficiency. So you can choose any filter you need. It has pre-built in it, what is the pressure drop, how much it's gonna cost. And also any type of air cleaner you want, it's also here. I hid a lot of these rows because I know I needed to fit them on one slide. Also, you can choose what strategy, what type of building, etc. So let me show you an example. Here I have an office building in Boston, 50,000 square feet, 250 people. They have the minimum outside air per ASHRAE standard 2.1, and they have a filter that's MERV 7, 2 inches. And remember what I told you about the filter that you can get them? This is an example of efficiency and pressure drop. So pressure drop versus airflow for different depths. If you go and plug in the filter, it's gonna give you all this output. So you can plug for a certain output, and also the calculator has an ability to compare many different scenarios. So here I compare, what if I have 100% outside air? What if I have prescriptive plus 30%? What if I have prescriptive VRP or IQP? And what's the different, basically, efficiencies? And also you can add the air cleaning. Here I have 0 because I didn't assume I have an air cleaning. More than this, there's an ability to display nicely the data for your clients. And this is something I always get. How can we show our client that we did enough, or the parents? So there is here basically the annual outside air plus filtration cost, including the maintenance. And the bubble size basically, I apologize if there is a problem with the formatting, but basically the bubble size is the cost. The way you read this is 100% outside air. You can achieve 6 air exchange rate. You pay this much, and this specifically in Boston. You can definitely do it for Jordan. But you can actually achieve an excellent air exchange rate, 5 to 6, but way less costly than basically 85,000. It's only cost you this much. Again, this is specific for the rates and the climate in Boston. There's also a way to calculate cost per effective air exchange rate. So this is a metric I was talking about at the beginning, dollar per risk reduction or dollar per air exchange rate. Also, we had an interest to look at the carbon impact. I don't know if you have these efforts. I'm sure there's metric for sustainability, but also you can take a look at the metric tons of CO2 per year for different strategies. And here we do the equivalent of how many passenger vehicle. So for example, if all the buildings, for example, in Amman, they want to go 100% outside air, you can actually do it on a national scale and say, okay, how much we're contributing to more pollution. To give you this as an example. So here I calculated for all the US offices, the small, medium, and large, if all of them decided to choose a different strategy, what will be the impact on the climate? For example, if all of them, they have 100% outside air, it's equivalent to adding 28 coal power plants per year, imagine. And it's equivalent to add 23 million cars, passenger car. So, and the whole spiel here is that we don't have to compromise on our budget. We don't have to compromise our carbon impact. We can do this using the basic strategies of outside air or only particulate filtration and a fan and a filter, or add portable air cleaning in room and achieve a very good air exchange rate at affordable cost. And I put here toward the end of my slides, basically a decision tree. And this is start. And you can use that in preparing your pandemic plan. For example, the first thing is that, do I have an HVAC system? We might be dealing with buildings, they don't have even an HVAC system. Do I have ventilation? Do I have filtration? And if no or yes, calculate your air exchange rate. If it's not per your target, then add air cleaning. Again, fan and a filter. And if you don't have any ventilation filtration, then install air cleaning to achieve your target. Then you can do the optimization I talked about. You can estimate your risk or air exchange rate. You can estimate your energy consumption, first cost, operating cost, maintenance. Then you can do your flush out plan, implement, maintain, and document. Now, before I end, there is COVID-19 testing. There's a gentleman in the previous presentation, he asked, how can we monitor air quality? So before the pandemic, basically we had basically a new trend in sensors. Typically we have temperature level humidity, and in many Class A office buildings, we have CO2 sensor, carbon dioxide sensors. Carbon dioxide is great to tell you the sufficiency of ventilation, but it doesn't work well if you have filters. Like filters and carbon dioxide, they don't match. If you have filters, carbon dioxide low and high, it's not going to tell you much about it. But what I want to tell you here is that you can do COVID-19 testing, actual testing, and our clients use it in many different ways. Some emergency response plan. Some, for example, if you have if you have a break in COVID-19 cases and you send people to quarantine, how you know they are safe to come back, you can do this testing. The first one is a swab test. You can swab any surface. The second one is air sampling test. So you can go around in the actual room, and the air sampling test can tell you if all your strategies are working: ventilation, filtration, the masks, the social distancing. Both of those can tell you if the virus is absent or present, and what is the concentration. Unfortunately, it doesn't tell you if it's infective or not. So just like the key takeaways, we need to focus on the basics. The basics that work before COVID, during COVID, and will work after COVID. Please do not invest and waste money on fancy technologies. Just a basic of a good filter and a fan can do wonders. A little bit of outside air, if you can open windows, and if you don't have a problem with air pollution, can help you a lot. Maintain your systems, and anything you need to do extra, make sure you do it performance-based. Make sure you look at the data. The data is available. If you don't understand what you're paying for in terms of risk reduction, do not waste your time or your money. These are my social media handles. Feel free to follow me on LinkedIn and Twitter. I do frequently post about what I see in the field from our clients. And this is my email address in case you would like to have a copy of the energy estimator or a copy of this presentation. Thank you so much.
Thank you, Marwa. Thank you so much. I think was really a good brainstorm. Okay, let's open the door for questions. Do anybody has a question? We have here some questions, Marwa. Mohammed, you can read the question from the Q&A if you just click on the bottom. Mohammed, he's asking the filters. You already answered that question, I think. It's the question from the last session.
Yes, so this is a very good question. And basically, if I give you from the top of my head, a MERV 13 efficiency is 87%. If you cannot find a MERV 13 today, I'm aware of the shortage, you can have a MERV 11 that we call high performance MERV 11. So high performance MERV 11, as you see here in red, you can have a high performance MERV 11 that will help you, in a great deal. And then you can supplement additionally with some outside air or with portable air cleaning.
Okay. Mr. Saeed he sent thanks to you, Marwa, about the presentation. Same thing, Richie Mital. Richie, how are you? Richie is asking you, Marwa, where he can get the where he can find the instrument to check the COVID partial. I think he was asking about the air sampler.
Yeah. So basically, I looked in Australia. So in the US and Australia and also in the Emirates, I know the labs basically where you can ask them for this swab test and then send it to the lab. I don't know in your region where it is exactly, but I know there is a lot of international labs that ramped up to do this testing. Basically, it's a PCR test, but not for human, it's for objects. Now, this equipment, I basically personally bought from Germany. If you correspond with me, I can tell you. I don't work for this company, they don't pay me, I'm not on commission, and maybe there is a lot different, but basically what this instrument is a pump, and you have a filter, but then still you have to find a lab where you can send the filter. You can have the answer in like 1 to 2 days, but you have to look for a local lab. I'm not familiar with, in Jordan specifically, where the local labs are.
Okay, anybody want to ask a question? There is the Iba raised her hand. Iba, can you ask the question? If you have a question, can you please go ahead with your question?
Hello, good evening, Dr. Marwa.
Marhaba.
Marhaba, Muhandis. Actually, I don't have a specific question, but I couldn't stop myself from just thanking you, because you are like so smoothly giving us a lot of informations, a lot of data, and making it easy for us to understand how can we live with this pandemic. We as researchers, as architects, engineers, how can we like put this new thing, like the COVID-19 pandemic, in our designs, in our thinking. Especially, I am now doing a research about how can we build or live in building new buildings with specific let me say solutions for the COVID-19 pandemic. If I may say, how can we do a new environment in order to prevent us from getting this COVID? So I just wanted to thank you, Dr. Marwa. I really loved your presentation, and I hope we can get to know each other in person maybe after the COVID. Thank you very much.
Sure, no problem. It's my pleasure. And if I tell you here like a personal story, my mom is a teacher from south of Lebanon. I don't know if I should talk it in Arabic or in English, I'm not sure, but basically ماما بتعلم بجنوب لبنان وبدهم كان يفتحوا المدرسة، بس أكيد كانوا خايفانين من الكورونا فيروس وماما هي عندها حالة خاصة يعني she's a high risk، بس كانوا مصممين يفتحوا المدرسة for the Syrian kids and Lebanese kids. المشكلة بلبنان نحن ما عندنا الكونسبت of indoor air quality in general بالعالم العربي. فيعني silver lining to this pandemic is to bring this indoor air quality awareness. It's very important. I heard that okay, we have station for outdoor air quality. يمكن هذا الوقت to focus on the indoor air quality. And I know Rami is doing a lot of great work بالconference in general وبالتوعية. بس المشكلة مثلا بجنوب لبنان ما عندنا concept اسمه ventilation. ما عندنا concept اسمه filters like to start with.
Same as here مروة.
عندنا الكهرباء بس 12 ساعة من أصل 24 ساعة، ففي كتير challenges. وأنا يعني رسالتي إنه we can do this. We are all in this together and we can do it using basic technologies. Basic technologies منأكد إنه ترجع تشتغل حتى بعد كوفيد، وهذا بيكون the first path نحن بعالمنا كيف نفتح المجال ل good indoor air quality, good indoor air quality or acceptable or excellent indoor air quality.
Okay, Marwa, we have some more questions here. What do you think of air purifiers using the following technologies? HEPA filters, HEPA filters plus plasma technology plus heating up to 56 degrees C. Will that be efficient to kill the COVID-19?
Yeah, so I have to be, quite honest. I don't have a filter, but I have to be quite honest. My opinion, do not use anything that have electronic air cleaner. It's my personal opinion. I've been studying for this for a long time as a voting member of ASHRAE Standard 62.1 and looking at the test data. I actually vet these technologies like 10 to 12 of them each week. I did not obtain any time a test that tell me it's safe and it's efficient, specifically how it's installed in buildings. And I ask you the question, what benefit does it make if you add something on top of a very good filter? HEPA filters remove 99.9% efficient of the virus. If you have a very good fan and you install the filter, it can be ceiling mounted or in room, you don't need to do anything else. In fact, if I have an air cleaner in my house that have extra, I just disable the extra and I keep the fan and the filter. So this is my personal opinion, and I can tell you that you have to do your homework, you have to ask the right questions, because there are a lot of misleading marketing out there.
Okay, another question from Khalid. He's asking, how many times do we need to do air samplers or swabs for hospitals?
Yeah, this is like completely optional. So there is no like a set time. There's a lot of talk now about the rapid tests for people and also for like equipment. This is something that you have to decide in your plan. And also most importantly, you have to decide if you have a positive test, what you should do with it. So I don't have the answer for you. It really depends on what you're trying to achieve. Our emergency response plan, we're doing random testing weekly in dorms room. For example, in dorms room in a university in Florida, we do the test randomly every week. Take the test 2 days to come back, and based on that, we decide what we need to do. The nice thing about the test, it also gives you concentration. So if you're implementing a new strategy, for example, you might need to test frequently at the beginning to make sure your strategy is working and you're protecting, for example, the nurses and the doctors.
Okay, I think last questions or comments about having the presentation. We will make sure that everybody gets a copy from the presentation soon. And we have Zaid Nahas. I'm sorry, you raised your hand in the previous from the previous session. Do you want to ask any question or comment to Dr. Marwa? Mr. Zaid, do you have any question? Okay, Marwa, seems not.
Okay, I just want to say that also you will receive a link. This is a link that you can download the energy estimator if you're interested in doing energy analysis, energy and risk analysis.
That would be great. Actually, for everyone, what we conclude from also Dr. Marwa's presentation, that you need always to use an expert to decide what exact system of filtration you need. You cannot really judge from anybody that comes to you, okay, I have this kind of UV ionizers, blah blah blah. He cannot have the full answer for you. You have to let's say ask the experts, do your exercise, do your homework. Not everything can work in your case. Everything is case by case. Depends on large number of contaminants, less number of contaminants. So this depends on so many inputs. And we have seen the paper or the document that Marwa will share with us, the energy estimator. You have a lot of input data that you need to plug in. It's not a matter that you say, here is the size, here is the people, get the answer. It needs really an opinion of a real expert like Dr. Marwa or anybody who's expert in the air quality or something like that. You need to consult him, and it's not really shameful. It's very good exercise to ask always the expert, because we are seeing now the whole world is selling kind of filters in the world. Everybody talks about UV, everybody talks about cleaners, electronic cleaners, everybody talks about filtration. Correct or not, Marwa?
Yes.
And that's a big problem, by the way.
Yeah, you need to make informed decision. And I always say, if you cannot explain it yourself, do not buy it. If you don't know what your risk you're reducing, do not buy it. And most importantly, you know, you need like third-party data. If the manufacturers say 99.9% efficient, it's not enough.
Yes.
You need a test inside that mimic inside the condition. I can make any test to look 99%. Give me any equipment, I will get you 99% result. That doesn't mean that this 99% result will be the same when you install it in the HVAC system. There's the airflow speed, there's the residence time, there's the exposure. So, you know, if you take anything from my presentation today is you need to do your homework, especially if you have a limited budget, especially if you're dealing with like, you know, high risk, like schools, for example, you know, schools or elderly or something like that. So do your homework.
Okay, Marwa, we got a last question actually from Mr. Ahmed. He said how we can separate each room protected in hospital alone from other room from bacteria or viruses. I mean, yeah, this is the question, like how can we prevent the infection control? Is that the same question?
Yeah, and you know, luckily Ashley has done a very good job in the healthcare to do a lot of, you know, guidance about how to create an isolation room. And this is actually the same when we talk about if you are in your home and like your spouse or your kid or yourself, how to do a quarantine in home, how to do it in a school for the nurse office, or how to do it in hospital. So I don't want to do it like a short answer, but basically you need to make sure like you have the concept of a negative pressure room. So as much as you can, negative pressure room, and you have a specific bathroom. And if you were to put an air cleaner, you put the air cleaner with the person who's infected. I know this sounds counterintuitive. I have actually a paper coming in Ashrin in December that talk about how can we create isolation in homes. It's very important to put it in the person that is infected, not to protect him because he's already infected, but to decrease the disease generation. It's better to put it with the person's infected and create isolation. Isolation can be created in many different ways. Like in home, you can use a bathroom fan, or you can put a window fan, for example. In hospitals, you have a more sophisticated system, basically.
Okay, Dr. Marwa, thank you very much. We wrap up the presentation with a big, really thank to Dr. Marwa for being with us today. Thanks a lot, and we hope to see you in our upcoming third round of the conference next year. We'll coordinate with you. Of course, you are will be a very good asset for us.
No problem. Thank you so much, everyone, and stay safe. Bye-bye.
Okay, thank you. Goodbye. اوكي، يعطيكم العافيه جميعا. شكرا على يعني حضور الجميع ووجودكم معنا. وهلا عندنا اخر برزنتيشن بعد 5 دقائق تقريبا. معنا نيكولا جاودين من ايطاليا. Mr. Nicola, you're with us here. Hello, Nicola.
Hello. Do you hear me?
Hello, Nicola. Yes, we can hear you.
Okay.
Nicola, can you share your presentation and put on your camera?
Of course. Okay. Mazahula Hiri to everybody. Good evening.
Good evening for you. Can you share your presentation, please?
Yes. Do you see the presentation now?
Yes, it is.
Okay, great. So thank you very much to everybody. It was a long day, and I suppose that most of that you are a little bit tired. So I'll do my best to.
Let's give it 1 minute more. If anybody wants to bring water, bring some tea.
Yes,
and
yes.
We'll start after 1 minute or 2 minutes. Okay.
Yes. Okay. That's fine.
Okay, let's start now. Sorry, Mr. Nicola, you already okay?
Yes, I'm okay.
Okay,
So
1 minute. We have here Diana. Diana Hassan, do you want to ask a question or you raise your hand? Do you have any question, please? Okay. Okay, let's go ahead. Mr. Nicola.
Yeah.
Good afternoon for you.
Good afternoon. So
Thank you very much.
to everybody. Good evening.
I'd like to thank you very much for being with us today. I don't want to introduce you. I will leave the introduction for you to yourself now. You can start. Go ahead with your presentation. Your presentation will be about the importance of Jonix Air non-thermal plasma system in indoor air quality improvement and especially killing COVID-19 virus. So let's see what you have, and please introduce yourself. Go ahead.
Thank you so much, Rami. Thank you so much, Rami. It's a great pleasure to be with you. My name is Nicola Gardim. I'm business developer of Jonix Air. Jonix is an Italian company specialized in design and manufacturing of sanitization systems for professional use. So this evening we are going to speak about one of these magic technology. Fake technology. It's true there are many options in the market in our days, but what we have done is to test our technology, and we have several important installations in Europe, in Far East, and now also in Middle East to prove the efficiency and quality of our job. So let's talk about today's situation, and these are the topics. We are going to discuss about which is the effect of COVID-19 in our concept, the traditional concept of indoor air quality, which is the approach of the pandemic in 2020. And then we are going to talk about the non-thermal plasma. Non-thermal plasma, that it's something that was invented not by us, by Mr. Einstein, discovered this. And now non-thermal plasma is one of the most important technology, modern technology to fight the pathogens on air and surfaces. We have developed our own non-thermal plasma thanks to a very deep study on the electronical point of view of this phenomena, and I will explain in detail the results of our technology. So we know that starting with the concept that we spend from 80 to 90% of the time inside the building. So big part of our life is spent inside the building. So it's mandatory in our days to consider the importance of indoor air quality, since maybe some years ago when we were talking about indoor air quality, we were talking about mainly temperature and humidity level. Today is not enough. Today we have to consider many other aspects about indoor air quality. And take also in consideration that it's very clear now that in mostly of the cases, the indoor air quality is 5 times worse than outdoor one. So it's extremely important to study and to evaluate which are the main contaminants inside an ambient. Everybody is expert. All people that are participating to this important seminar are experts of indoor air quality. So we know that which are the main elements that participate to classify the quality of the air. So the presence of microorganisms like bacteria, yeast, molds, virus, but also the all VOC, the volatile organic compounds that are coming from paints, cleaning products, formaldehyde, so furniture, office equipment. But we have also other elements, the airborne particles like dust, smoke, fibers, the PM, and the household odors, gases. So all products that are coming from, for example, smoke of cigarettes, cooking odors, CO2. So all of them contribute to alterate the indoor air conditioning. But now the situation is different. And I'd like to share the time between 2 parts, before COVID-19 and after COVID-19, because we learned a lot of things. Before of COVID-19, our enemy were the traditional contaminants, what we have seen in the previous slides. That was the problem. We had to reduce the concentration of these contaminants to reduce the impact to the people inside the ambient, and so to improve the indoor air quality. And how we decide, how we proceed to do this. But the main goal was to adopt the technology to eliminate the source of pollution, internal pollution, to reduce the emissions of these contaminants, improving the ventilation. We had some very interesting presentations today regarding this topic, or to adopting some air cleaning systems. Something, this was the traditional approach to this topic. But after COVID-19, we have seen that this was not enough, because besides the traditional contaminants, we discovered the virus that is hosted by human people and also is hosted by bacteria. But not only. The virus we have seen that is present not only on air, but also on the surfaces. So we have in this moment to treat not only the air that is inside an ambient, but also all the surfaces inside an ambient. Furniture, wall, ceiling, any surface can be dangerous because we can find a concentration of bacteria over there, and we know that inside the bacteria there is a virus, because virus, as described also in the previous presentation, cannot live alone. He has to be inside a host, and the most common host is a bacteria. So which is the new target? The new target is to forget to consider only the indoor air quality, but to consider the indoor environment quality and safety, because it's not a matter today about only quality of life, wellness, comfort. It's a matter also to safety, because we have seen that in case of this virus, but who knows in the future, the ambient has not to be only comfortable, but it has to be also safety for us. So the main goal is to improve the indoor air quality and to eliminate all the pathogens present in all surfaces, because this the contact is one of the way how we can transmit all these diseases, and in particular the COVID-19. So we are in front of new challenge. the constant sanitization of air and surfaces. And this activity has to be done 24 hours a day, 7 days a week, 365 days per year. So continuously, we cannot stop these activities because we have no control about this virus. It was clearly explained that this virus is very small. It's a very small element that is very difficult to stop. So we have to protect ourselves with a strategy that has to take care about the quality of air and to sanitize in the same time all the surface inside an ambient. Because we have to protect ourselves and to improve the indoor environment quality and safety. This is a joke, we can say, but at the end of the day, this is what we have seen. On the left, the picture about the Spanish flu, the very famous Spanish flu that happened almost 100 years ago. And what it was suggested that time was to wear the mask, to clean the hands, to maintain the social distance. And today, what happened? Today is almost the same. They suggest us to wear the mask. They suggest us to clean the hands and to maintain the social distance, which is the progress. Only the selfie, the possibility to make the selfie. One funny thing that also 100 years ago, there were people that were not able to wear the mask properly. So it's like exactly today. But a part of joke, there was an evolution in technology, and we trust, in Europe, we are concentrated a lot in the R&D of new technologies to approach the problems. It's true that old and consolidated technology is reliable. It's true, but we cannot stop the progress. We have to look forward and we have to invest in R&D. And so this is the reason why today we are talking about non-thermal plasma. I fully agree that in the market you can find any fake products. I've seen in the market blue lights used to kill the mosquito and sold as a perfect solution to kill the COVID-19. This is common. We are living in a huge market. This is the result of a free market, but you have to be careful in the selection of your suppliers. Jonix is a leader in design of machines based on non-thermal plasma technology, because our target is to protect the people inside the building, any type of building, any type of structure. To protect means to guarantee the quality of air and to guarantee the constant sanitization of the surfaces inside the building. But what is it really, this non-thermal plasma? Non-thermal plasma, the plasma in general, it's a blend. It's a gas. It's a blend of ionized gas. We can consider as an evolution of ionization. It's an evolution. Yes, it's a right way to describe. It's a blend. It's a mix of really energized elements. So like ions, electrons, free radicals, molecules, neutral atoms. And all this mix of elements, they have a very huge energy, because the energy that we supply to the air, it's the same phenomena that you have after a storm or during the very, very sunny days. There is a huge concentration of energy that is spread to the air, and this air is charged of non-thermal plasma. What happened? Which are the performances of this technology? I fully agree with Dr. Marwan. It's really important to make tests, to make tests in independent laboratories, to make tests with universities, and to prove what we are promoting, what we are marketing. This is the cover of our scientific dossier. It's over 300 pages of case studies, tests done by third-party laboratories, tests done by universities. And so there you can find all single tests that we have done regarding our technology. Let's start with the biological effect. So what is important to say that with this mass of very reactive elements, we are extremely powerful in the biological effect, because we destroy the external membrane of the bacteria. because all bacteria, virus, spores, we destroy the external part that is used to feed the bacteria, because the electrons are used to stay connected the external part of these biological elements, and removing the electrons, because the plasma is very reactive and try to collect the electrons from the air, and in particular from the surface of these bacteria. We destroy the external part of the bacteria, the external surface, and so the bacteria is no longer able to feed itself, and it's killed instantaneously. So this is extremely important. We have done the tests. These are available in the dossier test that I'm ready to share with everybody. We have done tests with, here are some examples of very common and dangerous bacteria, as Escherichia coli, as Staphylococcus. And we have seen that even only after 2 minutes, the proliferation of these bacteria was stopped. We have done this test on open air, so in the best conditions for the proliferation of bacteria. And we have seen that there was the reduction of concentration. After 2 minutes, it was stopped, and after 5 minutes, they were completely eradicated. Obviously, that it was not possible to make this test on a air handling unit, or inside a supermarket, or inside, I don't know where. We have done this test, for example, in an operation theater. We have done this test inside a food laboratory. So all these tests are available, but these results are regarding the tests that we have done also inside the laboratory. But what is very important, that all these performances were also tested in a real field, so in real applications. Another important fact is due to the oxidizing effect. The oxidizing is the factor generated by the ROS, so reactive oxygen species. And these are very, all the products of oxygen, like O2 minus, OH minus, O pure, and all these ROC, they destroy completely the volatile organic compounds. This is extremely important to protect the people inside an ambient by all the contaminants coming from inside the ambient. So the products of paintings, the products of formaldehyde, the other products used to clean, the vapor coming from them. So this effect is extremely important, and it's really appreciated, especially in the rehabilitation center. It's very appreciated inside the hospitals, but also inside office building, etc. So this is one of the effects that is much appreciated. Another important effect is regarding the microparticulates, the PM2.5, PM10, because thanks on NTP, non-thermal plasma, it favors the coalescence of these microparticle. That in this coalescence effect, it means that more particles join together, and so at the end of the day, the volume and so the weight is enough to fall down, and so instead to have this particle free to fly on air and then to be breathed, they are on the floor. And this is extremely important to reduce the possibility to breathe the PMM. So this is a very important when we are very close to, for instance, to the trafficked road. I think about the big cities in the Middle East that are typically very close to the very trafficked roads. So where the concentration of PM is very high. With this technology, it's possible to reduce the concentration of PM present on air, and so to help all people with respiration disease. This is another important point. Talking about COVID-19. So COVID-19, we started the test in May, and we had 5 months test at the microbiology department of Padua University. Padua University is one of the 2 universities in Italy with Milano that are allowed to manage the COVID-19 alive virus. This test was paid by my company, but is not our property. The test is property of the university. So everybody in the world can ask to the university to check these tests. Obviously, we have done these tests inside the laboratory, and we spent 5 months to make these tests. It was not possible, repeat, to do the test inside a mall or inside a hospital, because it's clear why. But the fact that we have done the test in a laboratory, it was necessary to identify, to check if this technology is suitable to kill the COVID-19 virus, and it is. The light in my room, it's enough to illuminate my room, but it's not enough to illuminate an airport. But this doesn't mean that the light is not, it's a fake technology. It's simply not big enough. Indeed, when we select the device for an R&D unit, for a mall, for an operation theater or a supermarket, we select properly the size of the device, but the technology is the same, and the technology is suitable, is tested. We have been to kill 99.6 times 9 after the 0, okay, COVID-19 in less than 30 minutes. And this is the result of a test that is done by Dr. Crisanti, that is one of the most important researcher, doctor worldwide specialized in this field. And it's signed by him. So everybody can collect this test report, or I can supply him to check it, how it was done. We spent 3 weeks, almost 1 month, because it was written according to international standards, because each laboratory, each university, each research center all around the world can collect this test report regarding the Jonics non-thermal plasma technology and to check our performances. So this is the way to work in serious mode. We are not a fake company, and this is not a magic technology. So which are the effects of our products? At first, a massive virucidal activity against COVID-19 on air and on surfaces. It's really important to understand that the air, we transform the air that is around of us as a virus hunter. So thanks of the air that is around of us, we kill the pathogens present on this ambient, on air and on all the surfaces. So this is the big revolution, that is the air, the instrument to sanificate my ambient. It doesn't matter if my virus or my bacteria is on air or behind my table, because everywhere my air arrives, it kills the pathogens. In this way, I protect myself and I protect the people around myself, because I contrast constantly the spreading of any airborne disease. Because today we talk about only COVID-19, but we know there are many other diseases that typically in the winter season, especially here in Europe, where it's not hot and comfortable, the weather as in Jordan or in the Middle East, the temperature goes down, and so you have many diseases. But what say to me the doctors, my clients, the dentists, they say, we are really happy because all our staff is no longer stay at home for illness, because we protect our team from the other pathogens, from the contamination, from other diseases. We protect the people. The same inside the school. We reduce the absence for illness. This is extremely important. These are real results. It's not these are not my words, okay? We protect, I use the same technology for the decontamination of all surfaces. So this is very important, because we understood, we discovered with COVID-19 that also if I touch a surface that was in contact with the virus, I risk to catch the virus. So all surfaces are constantly sanitized. One important last thing is that the plasma, non-thermal plasma, has the capability to destroy any chemical and organic odors, because each odor is chemically speaking made by a chain of carbon atoms, and the non-thermal plasma cut this chain, and in order to see that, to have the fact that the odor is not longer detectable by the persons. So I destroy completely any odors, smoke odors, dust odors, humidity, cooked food odors, etc. How we generate it? Okay, as I told you, I supply energy to my air. I supply in the controlled way energy to my air, because the risk is that if I supply too much energy, very too much energy, the risk is to produce ozone. And as you know, ozone is toxic. You cannot use ozone inside an ambient where you have people. So the ozone has to be used during the night time, which is the and during the night,
Nicola,
during the lifetime.
The sound has a problem. Can you repeat just 1 minute before now? Okay.
Okay. I was telling. Do you hear me now better?
Yes. Yes.
No, I was telling that regarding how we generate the plasma, we supply energy to the air, but it has to be done in very careful way, and this is one of the secrets of our technology, that is to control perfectly the energy that you supply to the air, because the risk that if you supply too much energy, really too much, the risk is to generate ozone, and ozone is toxic. To supply energy, to generate ozone, you have to supply energy with voltages between 7,000 to 18,000 volts. We produce energy supplying energy at voltages that is less than 3,000. So there's no possibility to spread ozone inside the ambient. But there are many people that are using ozone for the sanitization, but because it's toxic. Do you hear me, Rami? Yes, I hope so. Because it's toxic.
That's clear, Mr. Nicola. You can go ahead.
Fantastic. Because it's toxic, it's used during the nighttime. It's used for the sanitization. And what does it mean? That during the daytime, when people started to enter in the ambient, there's no protection. Nothing happened. There's no way to protect yourself. So it's unuseful totally. So this is the heart of our technology. This is our emitters. Each one is handmade by us. So you have an internal part where you have the internal electrode, that is this part internally. Then you have the glass, that is the electric barrier. Then the discharge gap, that is the space between the glass and the external stainless steel net, where the air comes through. And in this way, with this device, we supply energy to the air. This is the heart of our machines, and you can find the same device in each one. It doesn't matter if it's a machine designed for a residential application, or a machine designed for an operation theater, or a machine designed to be installed inside an air handling units. So the non-thermal plasma, it's a natural pathogen hunter, because on air, it's looking for pathogens, because he needs to collect electrons. He needs to destroy the pathogens. And we produce a natural sanitization. There are no chemical products. We do not use any chemical elements to sanitize the air. The pathogens on air are killed. We are not stopping all bacteria, pathogens inside the filter. We are not stopping there, and the pure guy who has to make maintenance, he has to remove a filter full of bacteria with baby inside COVID-19. No, we kill all the bacteria that are present on air and on the surfaces. Moreover, we have seen in the tests that we have done inside a real operation theater, so these are tests available to everybody, that all the surfaces treated day by day with non-thermal plasma, they became inhospitable for the bacteria. So the bacteria colonies decrease day by day, in spite of the fact that maybe during the night we stopped the machine and we worked only during the daytime, because probably there is a sort of memory effect, and there is a massive reduction of the bacteria. This means that if you have an ambient that you start to treat with non-thermal plasma, after some time, after some days, depends on the size of the ambient, obviously, also all the surfaces will be less contaminated by the bacteria. So this is very important in any medical structure, but it's very important also in a catering company. It's important inside the restaurant. It's important in our houses. So this is an effect that was detected by this third-party laboratory who made this test, in a hospital. So this is very important. And it's 100% safe. So there are no side effects to the people. This is the reason why I can use 24 hours a day this technology inside an ambient, because there are no side effects for the people inside. Okay, this is extremely important, because we have talking about UV lamps. UV lamps are dangerous. As you know, in the sanitization systems with UV lamps, there are also presence detectors to stop the energy in case of people inside the ambience. In case the use of ozone, as we discussed a few minutes ago, ozone is used during the night time. So these are old style technologies, dangerous for people. Everybody knows, and has to be treated in a particular way, has to be managed in a particular way, but they cannot guarantee the protection when people are inside an ambient. With non-thermal plasma, you have a massive benefit, because beside the sanitization of air and surfaces, you have an improvement of the wellness conditions, because non-thermal plasma is suggested also to all people with respiration problems, like asthma, like allergies. And so we have a great benefit in terms of for the organisms, because it works much better. Which is our portfolio? Okay, Jonix is an Italian company. 100% of the production is made in our company in Italy. We have an R&D department, design and manufacturing. Obviously, that mostly of the tests that you will find in our scientific dossier are made by third-party laboratories or universities. So absolutely transparent. We have a complete range of standalone products with different sizes. The technology is always the same. The heart of this technology is always the same, but obviously, as my light is not enough to illuminate an airport, also in our technology, if the ambient is big, the same concept has to be bigger. The same technology has to be bigger. Okay, so we start from cube units that is typically used in residential or surgery applications, in the dentist application, like shops, etc. We arrive to mate that are typically used in the operation theater, in the food industries or laboratories. We have these devices, we call them inside, that are used to be installed inside ducts, inside air handling units, inside rooftop, but also inside fan coil. Which are the advantages? The first one is that we have no limitation in terms of airspeed. As you know, when we work with the UV lamps are not designed to sanitize an airstream. UV lamps are used this is an old style technology, are used to sanitize the surface of coils or some part of that under the light cone. With our device, we sanitize completely the airstreams without any limitation in the air speed. Moreover, we sanitize continuously, constantly, the internal surface of ducts. So we have this double effect on air and on ducts. Moreover, if this device is installed before the air handling unit, for instance, we sanitize completely the surface of coils, filter, etc. Why? Because the air is charged with non-thermal plasma, and non-thermal plasma, as we have told till now, sanitize the air and all the surfaces in touch with this air. We have no extra pressure drops. So this means that we can add these devices on our on any existing air conditioning systems without any effect on ventilation, without any extra power consumption. The power consumption is absolutely limited because we talk about few watts. We are not talking about many watts as with the UV lamps. A machine like this one, for instance, the power consumption is around 10 watts, okay? So very negligible extra power consumption. This is very important. We have a very compact solution to install inside the fan coil units with cabinets. So typically in the office building, but also inside the hotels, these are can be applied close to the coil in order to have sanitization of the coil, constant sanitization of coil and airstream. We have a special device, this is new, that is suitable to install inside elevators. Why? Because inside elevators, we know that it's almost impossible to maintain the social distance. It's a very, there is a part of the elevator that is the keyboard that is very dangerous because all people touch the keyboard. So because we learned that one way to transmit the virus is also to touch surfaces contaminated. In this way, we have the possibility to guarantee the constant sanitization of all surfaces, included internal surfaces, included the keyboard, without any side effect with the people inside, the passengers or the elevators. So this is important because we can guarantee in this way the sanitization 24 hours a day without any side effect. Some applications, it's very easy. I can tell you that honestly, before the COVID-19, our core business were mainly with medical structures, hospital, clinics, dentists, rehabilitation centers, and food industries. Food industries, big food companies, catering. Why? Because these two industries, these two applications, they are historically much more oriented to the sanitization, much more conscious on this. We have a big market in the Far East, in Korea, in Japan, where they are very, it's part of their culture. Now also in Europe, it's becoming very, very important. After COVID-19, everybody is looking for solutions to protect themselves and the people, the employees inside the ambience, inside the offices. So schools, we had fortunately, there are some schools that decided to adopt this technology to protect students and professors inside and to guarantee the constant sanitization of each ambient and each surface, sorry, and to reduce the absence for illness, okay? Residential, kitchen. One additional advantage is to remove all smells about cooking food. To reduce the VOC presence on air, to improve the respiratory function, to reduce the allergies that unfortunately are very popular here in Europe. Here by here, the number of people is rising with allergies, respiration allergies, and you have a greater benefit if you maintain, if you can contrast this kind of disease continuously with the sanitization system based on non-thermal plasma. Another very important application field is the hospitality, hotels, to protect mainly the employees, because you can sanitize perfectly the room, okay, to protect the clients, but also it's very important to protect the employees. Ideal in Dubai, for instance, for the managers in the hotels, it's really important to protect the employees, because if you have only one employee with COVID-19, the risk is to be forced to close the hotel. So it's very important to protect our team there. We have also portable units like the Minimate that can sanitize completely air and surfaces of a room during the housekeeping process. This is one of the applications, but there are many, many others. There are ductable units that can be integrated with ceiling mounted fan coil to have the constant sanitization and also odor abatement, because it's a common experience that you ask to have no smoker room. I don't smoke, so I ask for no smoking room in the hotel, but probably some guests before of me smoked in the room, so you feel the smell of smoke, in spite you selected the no smoking room. So with this device, you cancel completely the odors, not only on air, but also on all furniture, because you destroy you cut the odors, as I explained to you before. Food industry, they are very, their mindset is to improve constantly the food safety, to improve constantly the hygienic level. So I fully agree with Dr. Marwa when she said that it's important to use a multi-layer defense strategy. There's no only one technology, magic technology suitable to solve any problem. Multi-layer solution is important. So we combine, our clients in the food industry, they combine their strategy, their cleaning strategies with our technology to reach all that places that cannot be reached daily, to guarantee to avoid the food contamination, direct food contamination, indirect food contamination, cross food contamination between, for instance, vegetables and meat. All these type of contaminations are constantly contrasted by our technology. Moreover, contrasting the bacteria proliferation, we improve the shelf life of fresh products. So we have a big market also in the industry of food, fresh food distribution. Laboratories, it's very easy to understand why in the laboratories, okay? We have portable machines or units to fix on the wall or on the ceiling. Operation theaters, typically we offer this machine that is the mate. In this case, we have integrated G4, F7, H13 filters, an HEPA filter. Why? Because if you want to speak with the doctors, you must speak, you have to introduce your technology with HEPA, because HEPA is well known by everybody. It's still, there is still this idea that if in a machine you have an HEPA filter, the machine is good. So we decided to introduce the HEPA filter, but it's not needed. We have it. We have a plug fan on board to control the fan speed. We have a touch screen system by Karel it's fully programmable. And this is the most sophisticated machine that we have, and it's typically used in operation theater. But the same technology can be applied also in the big kitchens for restaurants or for catering industry. The last example, but this is one of the last, it's regarding, as I told you, in the fresh products warehouses, that could be fruit, vegetables, flowers, because in this case, I control the ethylene production, and so I have a ripening delay. So I can improve the shelf life of my products, and so to protect them, to reduce the waste material. This is extremely interesting and also the economical point of view. One of the last experience that I had, it was in the Gulf area, where there was a residential towers, and they had a problem with the smell of waste, because on the base floor there was the waste collection room, and the designer put the air conditioning system dampers too close to the waste collection room. So we upgraded this room with our steel device in order to destroy continuously the odors. So you have two benefits. One is to reduce, we can say, to stop the bacteria proliferation, and on the other side, to destroy any chemical and organic odors. And so we fixed the problem in a very hot ambience as Dubai. Other applications, it's up to you. There are, we have an application in airports, we have application in the shops, mall, cinema, etc. So one of the most important things that our devices can be really applied in any kind of installations, because each one can be developed, can be sized according with the needs of the client. So these are the performances at the end in terms of benefits, and these are a part of the certifications that we have. So recently also our device has been certified as a medical device class 1. Okay, we are also on greening certified, TÜV certified, and we have been mentioned by European Union as first class innovation ideas. So seal of excellence. So these are proof of our the quality of our products and the behavior of them. So that's all for me. For any question, it will be a great pleasure to answer to you. In the meantime, also, if you are interested to receive our scientific dossier through Mr. Rami or directly, it will be a great honor for me to share it with you. And after that, any question is more than welcome.
Thank you, Mr. Nicola. Thank you so much for the presentation.
My pleasure.
And as everybody seen, we have every kind of technical opinions. And Mr. Nicola will answer the questions right now if you have any question. We have here, Mr. Nicola, around like 13 questions. Let me try with the question of Mr. Richie Mittal. Mr. Richie, can you please say your questions if you would like to interact with us? I just want to put you in. Mr. Richie, hello.
Yes, good evening.
Good evening.
First of all, let me introduce you. Mr. Richie, thank you very much for being with us. Mr. Richie is the president of the ISHRI, the Indian Society of Heating, Refrigeration and Refrigeration Engineer. And he is as well part of the board of directors of IAQA for the past years. And he is also one of the well-known ASHRAE leaders in the region at large. So that's a pleasure for us, Mr. Richie, to be here with us. Please go ahead with your question to Mr. Nicola.
Thank you, Mr. Nicola. It's really like the product, and thank you for a great presentation, I would say. And Khalil, I'm very happy that Rami, that you are doing an excellent job. I would say that you are connecting people and you're talking about air quality. Really proud of you. Thank you. So my question, there are two questions. One is that is there any byproduct for your technology? Because you have any byproduct?
What does it mean, any byproduct?
Byproduct, I mean, is there any ozone generation or something like that?
No, okay, I understand. The ozone production, if you check in the literature, when you have a voltages, when the energy is supplied to the air as a voltages that is lower than 3000 volts, the concentration of ozone is lower than 0.03 ppm. This means that production of ozone is limited, surrounded the emitters, and not very far to any limits emitted by law. So there is a limited production of ozone, not zero, okay, but it's negligible, and no single part of ozone is spread inside the ambient.
Thank you. And so, do you have any UL certification on this?
UL, not yet. We have, I have personally a couple of clients. They are exporting their devices in US, where inside it's installed my component. One is producing rooftop for airports and for the fingers of airports, and they are exporting their devices in the US, and it's integrated with my machines, but we have not directly the UL. We are thinking about this.
So my question is that you said that the ozone is very, very limited, but in a recirculating mode, have you ever checked what is the concentration may go up? How much has it gone up or something? Any data on this?
Okay, regarding the concentration of ozone, we have seen the ozone disappeared. So the concentration reached the zero value after less than 1 millimeter far from the emitters, because it's recombinated with the other elements on air. So the ozone is detectable in a concentration that is under 0.03 ppm in a surrounded of the emitters that is less than 1 millimeter. This means that after, I don't know, 2 centimeters far from the emitters, there are no ozone.
Thank you. And do you have anybody in India at this time or no?
Not yet. Honestly speaking, now I'm in contact with a couple of companies that are companies. My contacts, because I had the pleasure to work for many years in India. I've been there almost 50 times. And so I good network of people there. And I'm starting to move the first steps there.
Thank you, Nicola. And I would like to have more literature on this. So if you can email it to me.
Absolutely.
And I'm going to just send you a small mail so that you get connected. Thank you very much.
Yes, please. Take note about the email, my email address, and then contact me, and it will be a great pleasure, sir.
Thank you. Thank you. Thank you, Rami. I'm done. Thank you so much.
Have a nice day. Okay. We have a question from Mr. Zaid. Zaid is asking you, what is the what is the, let's say, what do you advise about the wavelength of the UV light emitter? Which nanometer of light
regarding
for AHUs?
Regarding UV light,
yes.
Which are the differences? Which are the differences?
He's asking you for AHU, which nanometer wavelength is recommended?
I don't have UV lamps. My technology is completely different. This is, be careful. I'm not our technology has any connection with UV lamps. So when you ask me anything about UV, I have no information, because we are working with a different principle. We have it's a apple with pears. We are comparing two different things.
Okay, fine. Mr. Zaid, the best UV light, I mean, for the germicidal side is like around 260 nanometers, just for information, since you asked the question. Okay, we have another question from Mr. Zaid himself as well. Bacteria and germs. Hold on, let me just translate for you.
Yeah.
He's asking whether the test has been done on your products was effective on bacteria in both, let's say, microbial pathogens, bacteria and viruses, despite that the virus is much smaller in size than the bacteria. Was it effective on both bacteria and viruses?
Yes, absolutely. Let me explain detail. When we have done, or when we do a test regarding the bacteria, in such case, the test has to be done by a couple of universities in Italy. One is specialized in the food industry. The other one is specialized in food process, excuse me. And the other one is specialized mainly in the biologic, it's the biologic department of Pisa University. Then we have done tests in third-party laboratories, international laboratories, and the bacteria, we have seen the effect on the bacteria destroying the external membrane. When we talk about virus is typically inside the bacteria, because the virus cannot live by itself, because it is not able to reproduce itself. So it has to live inside the body. It could be inside the human being, it could be inside the bacteria. And so the tests that we have done are done, and you will see, if you would like to receive a copy of the test reports that we have done, cultivating, producing, multiplicating the concentration of virus, and to check the effect on them.
Okay. We have some other question like, okay, we have Mr. Ahmed. Mr. Ahmed is thanking you for the presentation. And we have another question about UV. At the time of where the building is occupied, UV lights, when they use UV lights actually, I didn't get the question. Okay, it's a comment, okay. Mr. Zaid, using the UV lights while human beings are there. What do you say about that, Mr. Nicola? What are the concerns about using UV lights while the building is occupied?
But at first, this is not the right way to use the UV lamps, because if you check all the serious companies, they produce UV lamps or UV systems, they supply also the presence sensors, because UV can be very dangerous for the skin, for the human people. This is one example. So it's important that UV lamps, must be used, must not be in contact the lights with the skin, with the persons, because there is a cancerogen effect. We have some in the operation theater, there are lamps, for instance, with the present sensors that switch off the lamps in case of movement inside operation theaters. Also the robots, the systems on trolleys with the UV lamps, they have a sensor, present sensor. Or there are machines for the cleanness of the air, but there is a small fan and the airflow is very slow because the UV lamps are effective if only the air speed is lower than 0.2 meters per second. If the air speed is too high, there's no effect, totally no effect on the airstream. This is very important. Otherwise, UV lamps are used close to the coils in the air handling units, but not to sanitize the airstream, but to sanitize the surface of the coils. So yeah, there's no effect on the airflow. So this is one of the limits of UV lamps. Another limit is that the most how can I say, performing UV lamps, they have a shorter life. After we can say 9,000 working hours, there is a very important rating of performances, around 30, 35%, 40%. So the performances are not constant continuously. And talking about energy consumption, well, the power consumption for UV lamps is very huge and maintenance is extremely expensive.
Okay, Nicola. Another question we have from Mr. Ahmed Masri. Does the high relative humidity affect the efficiency on the effectiveness and the effectiveness of the non-thermal plasma?
Up to now, we haven't seen any effect. We have done several installations in very humid countries like Thailand, close also to the seaside, but there's no effect on the performances of non-thermal plasma, our non-thermal plasma, because non-thermal plasma is a concept, but how to produce the non-thermal plasma makes difference. And the secret is in the electronic device to control how you supply energy to the air, in which power, at which level, and which shape of the curves who describes the energy supply to the air.
Okay, there are some questions about the volume that the product can cover in the area. I just answered that we are going to provide them with some catalogs they are interested later on.
Yeah, let me add one short thing, Rami. Regarding the selection parameters. Selection parameters in general inside an ambient are at first the volume or internal volume of the ambient. Second point is the total airflow supplied by the existing, if it's available, air conditioning system, the percentual of fresh air, and the last point, number 4, is the purpose of this ambient. Obviously, that if I have to sanitize a classroom, is not like to sanitize an operation theater, and it's not like to sanitize an, I don't know, a shopping mall. So also the purpose of the ambient, the level of contaminants is important. We have classified 5 levels where we have collected some typical applications, and according with this information and internal volume, total airflow, and percentual of fresh air, we size properly the machine to install.
Okay, we have three to four more questions, and then we wrap up that presentation. We have a question from Mr. Khalid Musa. Does the non-thermal plasma replace the UV light or the ultraviolet in terms of disinfection? And does the non-thermal plasma also affect the medical devices like computers, MRI, stuff like that, or server rooms?
Okay. First point, yes, of course, non-thermal plasma is the new technology to replace the old one, to replace UV lamps. This is very important because UV lamps, as I told you, and as I repeated several times, are used mainly to sanitize a surface where there are no movement, and then I can sanitize this surface under the cone of lights. In the same way, with non-thermal plasma, I sanitize completely any surface touched by the air. Effect on the electrical devices like computer, etc. Not at all. Moreover, any electronical device produce positive ions, and positive ions are very negative for the well-being, for the human body. With the non-thermal plasma, I contrast the positive ions with negative ions present in non-thermal plasma. The final result is to contrast these positive ions, and I have a massive benefit on the environment. Our devices are installed inside operation theaters, so in presence of all electronic devices used for the operations without any side effect, obviously.
Okay, there is two questions similar to each other from Khalid and Mr. Ahmed Masri. How often do you change or replace the emitters?
Okay, the maintenance is very important because it's very limited, not comparable with other technologies, because every 1,000 working hours, we ask to remove the dust that could be present over the emitters, just because the dust represents a sort of barrier in the process. So it's very easy. It's an operation that takes 5 minutes, 10 minutes maximum. With the tissue, you remove the dust and you refix. And after 14,000 working hours, 14,000 working hours, we recommend to replace the emitters. It's like to replace the light in. So it's an operation of 5 minutes. Very, very, very easy. Can be done by the end user, or in case the maintenance process is very quick.
Okay, another question from Mr. Ahmed Abanda. He's saying how backward to electrical autoclaves. On what position we can kill all pathogens using 2 discharge plates? Okay, and we have a breakdown voltage and dielectric strength of gap, and we have several microbes which have their own convenient characteristics. He's asking about autoclaves and how he can use the position of the filter that can kill the pathogens inside it.
But okay, generally speaking, we have seen that the best you have two effects. Depends on what you want to reach. If your target is to sanitize continuously, to kill the bacteria present on the filter, obviously that you have to install our device just before the filter, because in this way you charge the air before that the air cross the filter, and so the air that will cross the filter will kill all the bacteria that have been stopped in the filter. If the target is to sanitize the distribution ducts inside the building, so to sanitize all the internal surface of your ducts inside the building before that the air will be spread inside the building itself, we suggest to install a device on the delivery side of your air handling units. That are the typical positions. So you can install one before to sanitize continuously the complete air handling units, and more elements. It depends on the airflow, depends on the layout, etc., to have a correct distribution inside the building, inside duct and inside the building.
I think Nicola is asking about using the device inside the autoclave to disinfect the autoclave itself, where they keep some samples.
Okay. I'm sorry. Okay, autoclave. I have one experience about one of my clients that is a laboratory. They use autoclave for the sanitization of all instruments they use, and they have planned some, how can I say, cleaning steps during the week where they put one of our machines inside the autoclave and we sanitize it internally. This is experience that I've seen.
Okay, Nicola, we have a couple of questions about the selection of that one. One question, like we'll ask the three in the same time because they are related to each other. I will summarize them. One gentleman, Diana Athamne, is asking you how to select the suitable non-thermal plasma for different size of AHUs. And there is another question, how you can install them in the AHUs and whether you recommend to use them before the coil or after the coil.
Okay. Number one, regarding the selection with air handling units, it's important to know which is the total airflow of these air handling units, the percentage of fresh air, and it's really important to know the volume of the ambient that we are serving. Because going back to the previous presentation, it's important to know the air change rate. Because if inside my air handling units, I elaborate a volume of air that is, I don't know, 2 times, 3 times, 6 times the volume of the ambient, it means that much frequently, for instance, in 1 hour, I have the possibility to sanitize the air. And so less devices I will install. It's a matter to know the total airflow, percentage of fresh air in relationship with the volume of internal ambient served by this air handling unit. With these 3 informations, immediately it's possible to size properly the number of devices to install. Where to install them? Okay, to install typically depends on the layout. How long are my ducts? Typically we put on the delivery side of a air handling unit the elements, and then according with the layout of my ducts, I can decide to put 1 or 2 elements also in the evolution of the ducts in order to guarantee to renew the sanification of the airstream. Where to install? We suggest to install before the coil. Why? Because in this way, the air that comes through my machine will be recharged of non-thermal plasma, and it will invest the coil. In this way, I can guarantee the constant sanitization of the coil as well. So it's not needed anymore any UV lamps to sanitize that coil.
Okay, and about using it in the AHUs and central cooling units, whether you prefer to use it before the coil or after the coil, or where exactly the best location for the NTPs?
Okay, obviously depends before the coil. As I told you, it's for me, for us, it's the best position. Also, it depends if you have space inside the coil to install this device. We supply also a special accessory where you can fix our devices and you can install in a section of the air handling units, but it has to be designed in advance. If we are talking about a refitting system, revamping system, so the air handling unit is already existing, no problem at all, because instead to install my device inside the air handling units, I can install the device, 1 device or 2 devices, it's up to the size of this air handling unit, on the return duct. So all the air that is coming back from the ambient will be charged by non-thermal plasma, and then it will invest my coil, my filter, my fan, and so I will the sanitization of internal surfaces of my air handling units. After that, out of my air handling units, on the delivery side, I will install other elements according with the sizing, according with the calculation that we have done, in order to guarantee to have an airstream charged with non-thermal plasma suitable to clean internally the ducts, to avoid the proliferation of bacteria colonies as Legionella, for instance, and to spread the non-thermal plasma inside the ambience.
Okay, Mr. Nicola, 2 more questions. One from Mr. Zaid. He's asking you whether your product or whatever product line has got approval from WHO or FDA or something like that.
Okay, now FDA is American, if I'm not wrong. Huh?
Mm-hmm.
Up to now, we are starting to approach the American markets. We have all European certifications. We have certifications from Hong Kong. We have, because our main market from Korea as well, but nothing from US. Not because we are not able to reach the hair standard, but simply because it's not our market yet.
Yeah, for just seconding this, the WHO is not a third party to certify products.
Sorry?
Okay. I mean, he's asking about WHO. I'm telling him that WHO is not a third party to certify products. Oh. Okay, the last question we will take is from Dr. or Engineer Iba. She wants to talk and she wants to ask Iba. We will give you the.
Good evening, Mr. Nicola.
Good evening. Nice to talk with you.
Nice to talk to you also, and nice to meet you virtually. First of all, I would like to thank you for the rich lecture that you gave us tonight. And the good thing in COVID-19, we are now all together from different places. I'm talking from Baghdad, and we are getting together from a simple screen. So this is good. My question to you is, do you think that your device, or may I say system, the non-thermal plasma, does it work in our region, like the very dusty and hot weather? I mean, does the weather type, which differs from region to region, affect your device or your product?
Thank you very much for your question. At first, let me say that I fully agree with you. This is a big opportunity to join all experiences, all know-how, to reach one common result, that is to protect ourselves and to improve the quality life of everybody of us. Regarding the performances of our technology, I can tell you honestly that we have installed in Europe, we have installed in Far East. I have personally, I'm in charge of GCC countries. I have installations in the Gulf, in Qatar, in Saudi, in UAE. And in that countries where there is a huge dust, you are fully right. Dust is a problem. It's a problem for a filter, it's a problem for my technology, it's a problem for everybody. It's really important in any air conditioning system to protect internal components by dust, because the dust is a sort of filter, is a sort of barrier to any activity of my technology, but it's dusty, the sand coming from outside it's a problem also for a filter. So what we suggest, but this is a common knowledge in these countries, is to have a good filtration system for the fresh air, to avoid to collect too much dust from outside, to have filters, functional filters, to protect by dust the internal devices of air conditioning systems, and to improve, to guarantee a good service, to clean, to protect the products. Fortunately, the service activity on our device is very basic, very basic. Everybody can frequently to remove the dust, just to avoid, to reduce the performances of the products. So fortunately, it's very simple, but I fully agree with you that one of the main problems, not only in the Middle East, obviously, is to guarantee that to avoid to have too much dust inside the machine, inside the devices. Regarding the temperatures, there are no effects about the temperatures. No one of our product is designed to be installed outside. So also the ductable units must be installed internally to the building, not on the roof, for instance, or at least if you install outside on the roof of the building, we ask to create a sort of box to protect themselves. So that is these are the limits that they have. But in terms of temperature, humidity, there are no problems.
Thank you very much for your answer. Thank you very much.
You're welcome, and thank you very much for your question.
Mr. Nicola, we have a couple of questions also. Yes. Mr. Omar Batman is asking you a question about if your device can kill beneficial bacteria for human body, which can be inhaled through human respiratory system. Can they do that?
Yes, this is the point. It's a stupid system. At the end of the day, the system kills bacteria. It doesn't matter if they are good or bad bacteria. I give you an example that it's possible because we supplied our technology to a dairy factory. They produce cheese. And you know that in the cheese production, there are some bacteria that are very useful bacteria. They are important for cheese. And so it was necessary a long period of tests to set up properly the machines. It was involved in the technical department to be sure to avoid to kill the good bacteria. I don't know, honestly speaking, what they did, but as far as I know, I have to be honest, we have not the possibility to distinguish good bacteria from healthy bacteria, dangerous bacteria. We prefer to consider the positive effect to kill the dangerous bacteria.
There is a question that we answered on from Mr. Ahmed. Please, my question regarding if we can use one unit as a station unit in central AC in hotel or hospital. Yeah, I think we did answer this question. The answer is yes.
Absolutely, absolutely. Hospitals and hotels are typical application. Hospitals, they have a very high knowledge, and these are used in a hospital. Hotels as well, because you have a crowded ambience, you have people coming from everywhere. So these are typical applications that are now, they are looking for solution for this about these technologies.
Yeah, we have another related question from Mr. Ahmed Masri, whether do the technician or anybody needs special training to install these equipments in the duct or anywhere?
No, I can share with you the technical manual. It's a very easy thing. Take in consideration that is a plug-and-play solution also for ducts. At the end of the day, you can connect with RS485 with the BMS, if the BMS is available in the building, so you can control by remote the status of this device. But it's a matter to create a hole in the duct, to fix with a stainless steel screw, and to connect the energy and the cable for the control. That's it.
Okay, Nicola, last question from Mr. Arif. Mr. Arif, thank you for the greetings and compliments. He's asking you how is the device, how the device can disinfect the surfaces.
The services, what do you mean, services?
No, the surfaces.
Surfaces. Surfaces is easy because let's imagine that in your surface you have bacteria, okay? All the air that is charged with non-thermal plasma is in contact with the surface. So automatically the air charged with non-thermal plasma kills the bacteria that are on the surface. It doesn't matter if the surface is this one, under here, everywhere. All the surfaces where we have a colony of bacteria are sanitized by the air, because the air becomes the hunter of pathogens. It's the air that is around of us, that is a protection against the bacteria. It doesn't matter if they are on air or if they are on the surfaces.
Okay, Nicola, last question we got another question from Mr. Omar also. Do you think that your device after long run will affect the human neurosystem or the vision of any human beings?
No, we recently we had also the certification as a medical device, and one of the several tests that has to be done to get this certification was to be absolutely safe for people. We have no evidence, not at all. All tests that have been done by external authorities has certified that our device is not dangerous, and so can be certified to be used for medical purpose. So I'm fully sure about this.
Okay, Nicola, thank you very much for the presentation, and it was really helpful and useful for many people. It was very good interaction also with our audience and attendees. And with this week of our today's presentation and first day of the conference is wrapped up right now with Mr. Nicola's presentation. We hope to see everybody tomorrow. Tomorrow our program will start from the, let me share with you the tomorrow schedule. We will start from the 12 p.m. and at that session we will start with the panel discussion about the need of healthy buildings. Then at 2 o'clock and between 2 to 3 o'clock we will start another session with Engineer Rawan Khattab. The first session between 12 to 2 about the need of healthy buildings post-COVID-19. We will have a very let's say, distinguished lecturers with us, Dr. Yasser Abu Hashim and Dr. Amir Julkhadar and Dr. Saban Sirat and Engineer Yasmin Saudi. And myself will be the moderator of that session. After that, we will have Mr. Engineer Rawar Khattab. She will talk about the impact of mixed land use on sustainability and indoor air quality. At 4 o'clock, we will have another session by myself. I will talk about the critical spaces, and we will talk about the required ventilation for laboratories. And in terms of lab classification, that would be a very nice session for the people who are interested to know about the design of labs, how to ventilate critical spaces like laboratories. Between 5 and 6, we will have another seminar from our colleague in Panama chapter of Indoor Air Quality Association, Mr. Jose Espino. He will talk us about the ventilation for providing COVID-19 in non-healthcare facilities. The session between 6 and 7 p.m. will be dismissed because Andrea she has a problem and she's been admitted to hospital. So we will wrap up tomorrow our end of the conference at around 6 p.m. and we will announce for you the round 3 of that conference tomorrow. Thank you very much for being with us. We'll see you tomorrow, and I will leave the mic to Jill Ibrahim. He will talk to you about how to connect to the internet tomorrow and get into our conference. Jill Ibrahim.
الله يعطيكم العافية جميعا ونشكركم لحضوركم معنا في الزخم اللي صار من بعد الساعة 3. بخصوص المؤتمر بكرة لتسجيل المؤتمر، احنا اليوم راح بعد ما ننهي السيشن هاي أو الويبينار هاد راح يوصل لكل واحد فيكم سيرفي. بتمنى من الجميع إنه يحط تقييمه للمؤتمر لهذا اليوم، وبعد ما يخلص راح يوصلوا إن شاء الله خلال نص ساعة لساعة راح يوصلوا مني إيميل. هذا الإيميل فيه 2 لينك. اللينك الأول بدخلك على المحاضرة مباشرة بدون أي ريجستريشن. اللينك الثاني ريجستريشن، هذا للأشخاص اللي بدهم شهادة حضور في المؤتمر، تمام؟ واللي بفوت على اللينك وبسجل طلع كيف راح يكون النوتيفيكيشن هيك راح تروكم ومباشرة يعطيك ابروفد ويبينار ريجستريشن ابروفد. التوبيك السكند داي 15 راح نبلش من الساعة 11:30، وهي معطيك اللينك هنا مباشرة انك تدخل تحضر المحاضرات. هذا اللي بيسجل اللي بده حضور المؤتمر. اللينك هذا كان بيه انه شيرنج لزملائكم واصحابكم انه بيقدر يفوت يحضر المؤتمر بدون ما يسجل للحضور فقط. اما اللي بده شهاده بده يضغط على اللينك التسجيل. انا راح ابعث لكم هسه الايميلات. كل حدا سجل على المؤتمر اللي هو الفيرست داي راح يوصلوا ايميل بدون ما يفوت يسجل، راح يكون هو مسجل في بكره، راح يوصلوا ايميل النوتيفيكيشن انه هذا اللينك عشان تفوت عليه بكره. والله يعطيكم العافيه وشكرا لجهودكم معنا اليوم، وبتمنى انكم استفدتوا وتكون الامور كلياتها ممتازه بالنسبه لكم، وشكرا. مهندس رامي بدك تحكي شيء؟
لا، يعطيكم العافيه، تحياتنا لكم، مساكم سعيد.